So now I have a start webinar button. I'm going to pause recording. Well, good afternoon, everyone, and welcome to the 2023 Environmental Water Quality Conference. I'd like to thank you all for taking the time to be with us here today as we discuss some interesting topics. My name is Brian Walsh. I'm the Public Affairs Director with the South Dakota Department of Agriculture and Natural Resources, and I'll take us through the session this afternoon. We're excited again to partner with South Dakota Association of Environmental Professionals to put on this conference. We've had some good discussions about the conference in recent months, and we'll continue to do so moving forward. Just excited to touch on some interesting topics this afternoon and spend a few hours with you folks. A couple of housekeeping items before we get started. We're doing a virtual conference again this year. It's in webinar mode, so as attendees, you shouldn't have to mute or anything. That should automatically be done. And you should be able to use the Q&A button to submit questions you have. And at the end of each presentation, we'll work through those questions and try to get everybody the answers they need. If you were wondering about getting your professional development hours from participating, that is definitely an option. We just ask that you email Brian Ferris on my team to get those forms. And I added Brian's email into the chat function, which I hope everyone can see. We're recording the event as well. So our plan would be to put the recording up on the department's YouTube page after the event. And we can sure share that link with folks if they want to see something again or share with others. Finally, we're going to do our best to stay on time and be respectful of all of your time and our presenters' time. That said, we will do a rolling schedule, and with just an afternoon session today, we won't have a break. So we're just going to push on through and hopefully be on time done at 4:15. So without that being said, let's go ahead and get started. I guess good, bad, or otherwise, I'm your first speaker today. So let me pull up my presentation here. One second, I think I did that incorrectly. Try again. So Brian Ferris, are you seeing my screen out there?
Yes, I am.
Okay, thank you. All right. So here's what I'd like to talk a little bit about today. I'll give you a little introduction for those of you who don't know me. My name is Brian Walsh. And I have been with the department either on the DENR side or the DANR side since 2003. So it'll be 20 years this June. I've served as in that time, I've served as a hydrologist and environmental scientist manager, and currently serve as the public affairs director. As the public affairs director, I work with a team that's responsible for the department's policy, communication, legislative activities, media relations, boards and commissions, our ag mediation program, and other special projects like conferences and doing things like this. So that's kind of who I am and what I do. I've been around for a little bit and been involved with this conference for a long time. So it's good to be back at it again. Today, I'd just like to talk to you a little bit about what the agency does, our agency overview, give you a little update on our 2023 legislative session, touch on briefly a few topics that we're kind of watching and working on that I think will be of interest to this group, and certainly take any questions. I only have slated myself for 15 minutes, so if I'm going a little quick, I apologize. And let's get rolling. So what does DANR do? Whoops, pardon me. Well, our mission is to protect and preserve South Dakota's agriculture, environment, and natural resources through effective regulatory services, natural resource conservation, and financial and technical assistance. And our vision is a South Dakota with a prosperous economy, diverse agricultural opportunities, clean air, clean water, and healthy families. And ultimately, we're a mission-driven agency. So when we're making decisions and deciding how we should act, we always reference back to this mission to make sure that we are staying on task. So what does the agency look like? That high-level overview. Our cabinet secretary is Hunter Roberts. He took over as the DENR secretary in 2019, I believe, or late 2018, and then has stayed on and seen us through the merger process as we've become DANR. In that office, the secretary is Darcy Kaiser, who is our finance director, Gene Goodman, who's our deputy secretary, and myself. And then the agency has 5 divisions. Gene does a little double duty. She also serves as the director of the Office of Water. Kent Woodmansey serves as the director of the Division of Agriculture and Environmental Services. Bill Smith, the director of the Division of Resource Conservation and Forestry. Andy Brules is our director of Financial and Technical Assistance. And the State Fair, which is one of our divisions, is led by Peggy Besh. Just to give you a little better idea what each one of those divisions does, I'll pop through a little more detailed overview here. We talked a little bit about my team, the public affairs team, and what we do. Of course, Darcy is our favorite person because she pays all the bills, gets us reimbursed for travel, and does all the important things. And we currently don't have a staff attorney. Hopefully we'll be filling that position sometime this year. So that rounds out the Office of Secretary. The first division to look at is the Office of Water, again, led by Gene Goodman. That has our 3 major water programs: the drinking water program, drinking water standards, OPSERT, surface and wellhead protection. That's our Safe Drinking Water Act program. The water quality program, that program is led by Mark Mayer. The water quality program, led by Kelly Busher, does water quality standards, surface and groundwater discharge permits, and stormwater permitting. And then our water rights program, led by Erik Groundland, our water permits, safety of dams, well construction. That rounds out our Office of Water. Our Division of Resource Conservation and Forestry is led by Bill Smith. That includes several programs, including the forestry program, which is led by our state forester, Marcus Warnke, who's out in Rapid City. Anything tree health, forest management, state forest action plan, windbreaks, urban and community forestry programs, all fall under Marcus's umbrella there. Our conservation program, led by Alex Rober, environmental scientist. He works with the Conservation Commission, works on conservation district funding, the coordinated plan for natural resources and soil health. The watershed protection program, led by Barry McGuire. Water body assessment, section 319, TMDLs, harmful algal blooms, and our riparian buffer initiative. And the program in that division is our plant industry program. Brenda Sievers is our program manager. Seed, nursery, pest control, state quarantines, EAB, and our honeybee program, Emerald Ash Borer EAB, is all wrapped into that plant industry program. So that rounds out resource conservation and forestry. Ag and environmental services, a largely regulatory program, has our air quality program, which is our delegated program from EPA. All of our air permitting is in that program. The livestock services program, that's our CAFO permitting, dairy and eggs and septic systems. Waste management, led by Jim Wente. That's our solid waste, hazardous waste recycling, landfills, asbestos, and pesticide container and waste collection activities. the inspection, compliance, and remediation program led by Terry Florence. That's our spills tanks program. Sarah Title III, brownfields are all wrapped into that program. The hemp program falls there, and then all of our pesticide related and feed and animal remedy programs fall under inspection, compliance, and remediation. And finally, the minerals mining and superfund program, which does, as you might think, mining permits, mineral exploration, superfund, oil and gas, and sand and gravel. Next up is our Division of Financial and Technical Assistance. That's our funding division. Have our environmental funding program led by Mike Perkovich. That's our water, wastewater, solid waste funding program. Petroleum Release Compensation Fund is in that program as well. And then the geological survey led by our state geologist, Tim Cowman, down at USD. They do our natural resources assessments, investigations, aquifer delineations, mapping, and our oil and gas initiative. And then finally, our state fair, which is a division of our agencies led by Peggy Besh with Candy Briley as the assistant manager. Just a little plug for the state fair. If you haven't been to the state fair, we'd sure love to have you come out. Couple of announcements on entertainment this year. On Friday night, we're gonna go back to and try some comedy, and Gabriel Fluffy Iglesias will be there Friday night. And then our Sunday act will be Lady A. And then we'll be announcing a Saturday act here in the next few weeks. But lots of good entertainment, lots of great egg related activities, and just good fun. So if you haven't been to the state fair, we'd sure love to see you come out. All right, so that's who we are. Oh, forgot a slide. We also, as a merged agency, have 20 boards and commissions that we have varying levels of responsibility for. Everything from the animal industry board to our commodity checkoff boards, and then what you would maybe more associate with DENR, the Water Management, Water Natural Resource Board, Minerals Environment Board. Those boards keep our staff plenty busy and cover a wide range of areas. So just another one of the activities that we are working on here at DANR. All right, switching gears to try to, the next few slides to give you an idea of what we've been working on lately and what we are looking at. We had a very busy but successful legislative session. We had 8 agency bills and then a 9th governor's bill that we supported. All 9 of those bills passed. I will give you a brief update on these and just to keep us on task and on time. Senate Bill 17, we had 4 appropriations bills. One of them, Senate Bill 17, was our annual omnibus water funding bill. That's the bill that allows the environmental funding program to dole out money for water and wastewater projects. Senate Bill 18 was a request for some additional funds to finish the decks at the state fair. If you haven't heard of that, a couple of years ago, the beef barn burned down, and we're replacing that with a new multi-purpose livestock and equestrian facility. Got some funding for it last year, needed a little bit more to put us over the edge to get that project done. And we will have that up and operational at the 23 fair, which we are very excited about. Senate Bill 21, you may have heard that the Black Hills National Forest is in the process of revising its land and resource management plan, which is something they do once every 20 years or so. And it really is a big deal and affects all aspects of land and resource management in the Black Hills. And it's just very important that our department and the local communities are engaged in that process. So this bill provided some funding flexibility, both for our agency to commit staff time to work on that and to create a one-to-one match program so local communities could have access to some resources to engage as well, as those communities don't always have the funds or expertise they need. So we're proud of that bill, and we had good support moving through the legislature. Finally, 1021, that was an act to appropriate funds for the State Conservation Commission. That's an annual bill, and it's part of how our conservation program works with the commission to give grants to our local conservation districts. So another good support for that bill as well. Switching from funding more to policy or fee bills. I'll touch on this a little bit later as well, but last year we had the historic bill that brought $600 million in ARPA funds available for water and wastewater projects. We needed to go back and tweak that just a little bit with Senate Bill 20. When that was first passed, we didn't really envision or have a mechanism to deal with deobligated funds that might not get spent out of that 600 million. Senate Bill 20 cleans that up, allows those funds to be reallocated through the normal Board of Water and Natural Resources process. So good bill, just something we need to get done so we can keep moving those dollars out the door moving forward. Senate Bill 92 related to digesters. You may or may not know that at our South Dakota dairies, there's been a good movement to add digester facilities to those dairies to, reduce odors and also create a product, a natural gas product that can be put into the gas line and used. We think that's a win-win situation. Many of the digesters are located at dairies and are covered under the dairies water pollution control bill, but there's or water pollution control permit, but there's the possibility that we could have one that is standalone or is taking manure from multiple from dairies. And we didn't want to have a situation where we had a digester storing lots of manure and not having to comply with our water pollution control requirements. So Senate Bill 92 corrects that and makes sure we have a fair regulatory playing field for those digesters. House Bill 1025 was a fee increase. We regulate bees in South Dakota. We register them and we help do inspections and promote bee health. And that's a user fee funded program. And we had not raised the fees since 2001. So we did some fee adjustments there to keep that program solvent and in good shape moving forward. House Bill 1028 related to our pesticide regulations. That's we have delegated enforcement authority from the EPA and FIFRA on the pesticide side of things. And we needed to make some tweaks so that we were remaining in compliance with the requirements of EPA so we could continue to control that program. And that's what House Bill 1028 did. And then the last couple bills, 1029 related to county zoning. I'll just give you the quick overview here. Over the last few years, there's been some tweaks to county zoning, conditional use approval requirements, and along the way, the voting requirements at the local level got out of whack between the county and the municipal side. And the purpose of this bill was to get the county zoning voting requirements back in line with the municipal, and created a situation where that board needed to have a majority to approve a conditional use permit, needed majority of the members present and voting, as opposed to the majority of the members elect. That matches with the municipal process and allows those boards to take action if someone, for whether they have a conflict or doesn't want to or isn't able to come and vote, can continue moving things forward. So that was a good bill. Move forward through the legislature. And finally, House Bill 1090 modified some of the existing protections in for agricultural operations to protect from frivolous nuisance claims. So that was very quick and fast. Apologize for that, but it was a very busy session for us. We had a lot of activity amongst many other bills we followed, but it was a successful session, and we're a little bit glad that it's over. So moving on, I'm already past my time here. I apologize for that. I'm just going to quickly touch on a couple updates. As we talked about earlier, in 2022, had the $600 million for ARPA funds. All that money has been obligated. That's 209 projects that were given ARPA grants. And in the process, we were able to leverage those grants with our SRF loans and local ARPA dollars. So all in all, that $600 million of grants was leveraged into $1.643 billion for water and wastewater projects across the state. Just a historic investment, and those projects are rolling out and getting underway. And we are very excited to have been part of that and help facilitate that progress. PFAS, you hear a lot about PFAS in drinking water. Just here recently, EPA announced its intent to set primary drinking water standards for 6 PFAS chemicals. That if it's not already, that soon will be out for public comment and review. And all I'll say at this point is that DANR is going to take a good look at those and comment as appropriate for our drinking water program. But just wanted to get that on everybody's radar screen if they didn't know about it. Dicamba, which is a powerful tool for our egg producers, but also over the last few years has had concerns with drift and drift complaints. We've sort of continually been looking at that over the past few years. And this year, working with the egg industry and product registrants, the product registrants then turned and submitted a label change to EPA to move the spray cutoff date from June 30th to June 20th. That's not done by us. That's done by the project registrants and approved by EPA. Across the region, we've seen an increase in problems associated with that June 30th cutoff date. Those higher late season temps can cause increased product volatility, leading to off-target impacts. Just moving that date back 10 days has been successful in other states. It's worked well in Iowa. So the product registrants did that, made that request, and in February, EPA approved it. So in 2023, that June 20th will be the dicamba spray cutoff date in South Dakota. Finally, just a couple of slides on our RBI program. I think we've talked to this group about that program before. Back in 21, we got $3 million to implement some efforts in the Big Sioux watershed, some cleanup efforts that turned into the development with lots of stakeholder input, development of the riparian buffer initiative, an attempt to get more of those acres along the streams in that watershed enrolled in riparian buffers. That initial push was not very successful. So going back and looking at it again, DNR has done a couple of things along with our stakeholder group to try and increase those incentives. Amounts to 2 real things, a couple of ways to pay more. So we're more competitive, either paying up to 250% of the NAS, which is the National Agricultural Service Statistics Service annual rates, rental rates for those lands, or to sort of pile on to the CRP and CREP programs to further incentivize those RBI requirements. RBI payments. We've had a little bit of success. We've got a first applicant enrolled, which is good, and we're hoping to see continued success in that. And then the other piece of that is we're going to offer some cost sharing dollars for the construction of animal waste management systems to assist some of the small and medium-sized animal feeding operations that are located close to those water bodies to get better control of their animal waste and hopefully keep more of that maybe out of the river. So that program continues to go forth. If you're interested or have questions about that, you can sure reach out to me or Tanner Clausen with our agency to get more information. All right, that was very quick and I went long anyway, but that's a quick wrap up for DANR. My contact information is on the slide in front of you. Any questions about what our agency is doing, you can always email me and I will work and my team will work to get you connected with the right people and who you need to talk to. So please don't hesitate to ask to do that. I don't see any questions in the Q&A, which is good because I think we're out of time and should probably move on anyway. So I'm going to stop sharing my screen. And move on to our next speaker. Kevin, are you there?
Yes, I am.
All right, Kevin. I'm going to do a quick introduction for you, and then you can share your screen and we'll let you take it away if that's all right.
Yep, very good.
So our next speaker today is Kevin Solie, and he will be talking with us about a case study of the selection and design of relatively simple groundwater corrective action for coal combustion residuals impact to groundwater at Basin Electric Power Cooperative's Laramie River Station in Wheatland, Wyoming. And Kevin, who joined Barr Engineering as a senior environmental engineer in March 2023, is recently retired, congratulations, from Basin Electric Power Cooperative as a senior environmental compliance administrator, where he worked on a variety of CCR issues at Basin Electric facilities in North Dakota and Wyoming. Kevin has earned both a Bachelor and Master of Science degree from the University of North Dakota with a major in geology and spatial emphasis in hydrology. In 2008, he completed a degree in geological engineering. Kevin is a registered professional engineer in North Dakota and Wyoming. Prior to his employment at Basin Electric, Kevin worked as an environmental scientist for the North Dakota State Department of Health, Division of Waste Management. He is also a retired commissioned officer of the North Dakota Army National Guard, having served 1-year tour of duty in Iraq. Welcome, Kevin. Thank you for being here, and go ahead and take over.
Okay, well, I might be a little shaky here. I'll see if I can share the screen, and I guess the backup plan, I think Brian Ferris has the slides as well, but let me give it a whirl here.
You bet.
Okay. Are you seeing any slides?
Not yet. It says you have started
Okay.
sharing, but I'm not seeing any slides.
Okay. Well, let me see.
There I see them.
Oh, they're up?
Yep, selection of groundwater corrective action is what it says.
Okay, all righty. Let's see here. Well, to get started here, again, and let's see, I'm gonna try to do something here. And you're still able to see the slides?
Yes, sir.
Okay, all right. Yeah, for whatever reason, my slides are just micro slides on the screen here. So I apologize. Well, and they're full size for the viewing audience.
Yep, they're full size for me.
Oh, okay, all right. Well, we'll get rolling here then. First off, I guess thanks very much for having me at the conference. And looking at the agenda, it looks like there's a lot of interesting topics that I'm kind of looking forward to. And I'm, again, happy to be a part of the meeting today. All right. Next slide up you should be seeing is, I guess, the introductions for the folks that worked on this. Know more about me, but I need to recognize Dennis Conair. Dennis Conair works for AECOM out of their office in Cincinnati, and he was instrumental in the development of the selection of remedy and just in general the monitoring at the site at Laramie River Station. And also not pictured and not mentioned, there was a gentleman by the name of Greg Summermeyer who worked on it before Dennis even and did a great job, kind of getting things rolling. All right, so here's the list of topics that I'll cover this afternoon. So first off, just a little bit about Basin Electric. You can see with the infographic on the right that Basin Electric has a very, I guess what I would call balanced generation portfolio. You can see there's about 40% coal, about 20% natural gas, and 25% wind, and then some others mixed in there. I guess the one thing that's I think interesting on this slide is that Basin Electric hasn't retired a single coal unit. So there have been additions of wind and purchases and natural gas fired units just to keep up with kind of member load growth and demand. On the right, you can see that Basin Electric is a very, very large cooperative. And Basin Electric itself doesn't have a single meter on anyone's house, but Basin is what's called a generation and transmission cooperative and sells power to our member cooperatives. And that number fluctuates, but at the time of the slideshow, it was about 140. And you can see on the map of the United States there that the member cooperative service territories, essentially run through the west central part of the United States from Canada all the way to Mexico. Here's this slide shows some of Basin's facilities, I guess our coal-fired fleet. Upper left is the Wheatland Old Station. That's the oldest plant. Upper right is Laramie River Station, which will be the subject of this presentation. Bottom left is Antelope Valley. And again, these are all relatively new facilities. And the very newest facility is Dry Fork Station in Gillette, Wyoming. And interestingly, the CCR facility at Dry Fork is not regulated under the CCR rule because the ash is disposed in an active mine. So it does not fall under the purview of the federal coal combustion residual rule. All right, let's jump into a little bit on Laramie River Station. Laramie River Station, or LRS, as I'll refer to it, is Basin's largest generating facility. So there are 3 units of about 570 megawatts each. They burn coal from the Powder River Basin, so it's mined near Gillette. And you can see on the graphic there are really kind of 2 major kind of CCR units or waste disposal units. On the upper right, you see what we call the emergency holding ponds, and why they were named that, I have no idea, but they are used mainly for water treatment waste, so lime sludge essentially, but they're also used for FGD, or flue gas desulfurization waste, in some upset conditions. So both of the, and there's a divider you can probably see in the emergency holding pond. So there's an east and west emergency holding pond, and that is monitored as a 2-unit multi-unit, if you will. And you can see the wells surrounding, the monitoring wells surrounding that CCR unit. On the bottom left, you can see the landfill, and then bottom ash ponds 1, 2, and 3. So Laramie River Station was planned in the 70s and constructed in the 1980s, and it's a zero liquid discharge facility. So that means no process water can be discharged, only essentially clean stormwater. So for water management, the plan is surface area. So Wheatland, Wyoming is in southeastern or southern Wyoming, and it's fairly dry. And so there is an awful lot of evaporation, and just by the sheer magnitude of the surface area of the ponds, they're able to keep water balance. Let's go back to the I guess the multi-unit facility, or the multi-unit groundwater monitoring site on the lower left. So that we have the landfill and the bottom ash ponds. And initially, when we fell under the CCR rule and started monitoring, we tried to do the everything as one large multi-unit, and things were going fairly well. But we did have one well that showed up that looked like it had some impacts from leakage from one of the ponds, perhaps, and we went to further investigate. And I'll get into that a little bit later. But you can see we have a lot of wells at the site, and a lot of wells that are very close in to the waste management units. The other things just to point out, on the kind of the right side, the east side of the drawing there's another what looks to be a surface impoundment, and it is, and that's the raw water pond for the plant, and then you can see the coal pile right below it. So I think we have the lay of the land pretty well. All right, here's a little bit backed out view of the site, and you can see that it's really an arid region of the United States and of Wyoming, and it's bounded to the north by the Laramie River. And you can see a lot of there's a lot of center pivot and flood irrigation, in the vicinity of the plant. And we won't delve into it this afternoon, but the irrigation return flow or infiltration from the irrigation may be having some effect on groundwater at the site. I'd say it almost certainly does. Backing out even a little bit further, you can see Gray Rocks Reservoir on the far right, so that there was actually, in order to provide water for the plant, there was a dam built and a water appropriation. And so water is pumped back to the plant for use. And the photo on the bottom left, off to the west, you can see the Laramie Mountains. So they're 15, 20 miles away, but I think again we have recharge coming from the mountains as well. The geology underlying the site is the Mercury formation, and it's really the whole site is just a sandbox. It's almost the perfect site to do groundwater monitoring because there's fairly decent hydraulic conductivity in the soils and sediments below, and so it's fairly easy to monitor. The other thing that was kind of interesting when we were drilling in the Mercury, through the Mercury formation, there are a lot of I'm not sure if they're root casts or animal burrows, but there's kind of lots of trace fossils that come up as you drill. So here again, the picture on the left, I think if you look closely, you can kind of see some of those burrows or root casts. They show up kind of a little bit whiter. There's a little bit more. I'm not sure if it's calcite or gypsum. Photo on the right, you can see the stratigraphy is fairly simple here. There's not a lot of folding or anything. It's just relatively flat layers. Like I mentioned, the groundwater is really easy to understand at this site, it behaves just like you would expect. It's almost, if there was a problem in a textbook for hydrogeology, it would probably have well placement and values that kind of mimic a site like this. You can see that groundwater flow is from south to the north, and so eventually it's going to reach the Laramie River. Fairly high hydraulic conductivity of about 2 feet per day, and again a relatively strong gradient. So things are moving fairly quickly at the site, and again it's fairly easy to monitor. So when we the CCR rule is actually constructed fairly well for the groundwater monitoring portion. So you start out with something called detection monitoring, and so you are looking for these various common indicator parameters, boron and pH and sulfate and the like. And so once you have you pop for statistics, you have a statistically significant increase for one of those what are called Appendix 3 parameters, those indicator parameters, then you would move into what's called assessment monitoring. And so you go from a suite of maybe 6 or 7 parameters, and then you add essentially all of the RCRA metals and then some to the monitoring list. And so it turns out that we had kind of, again, really small amounts of lithium and molybdenum that showed up, just slightly above kind of the significant levels. And so we had to do additional work. And so this slide, the title is, characterization characterization of impact. So another kind of term of art that's used is to determine the nature and extent of the impact. And so that's what this really is. So we put in additional wells, again, between the ponds. And so if you look at Ash Pond 3, so that's the big one, that's about 80 acres there on the bottom. There are the 4 wells that are in between. Those wells actually showed up clean. It was really amazing. So we knew the leak wasn't from Ash Pond 3. And we were able then to focus in on bottom Ash Pond 1. So we put in some additional wells to, again, characterize the nature and extent of the impact. And you can see the blue wells there. So there's, kind of what I'll call a cartoon plume there. But the 2 wells, the blue wells, were installed, and actually one of them is a nested pair. So we were looking for the deep, to see if there was any impact at a deeper level. And then it's not shown in blue, but it was another additional well. If you look way up on the top of the air photo on the north end of the property, so part of the characterization that's required in the federal rule is to put a well at the property boundary, just to make sure there are no impacts there. And sure enough, yeah, the TDS in that well was 300 or 400. So it was very, very kind of clean water and showing no impact. So I guess the good news is that the impact is fairly limited extent. So this one here shows lithium, and so lithium, for all of the drinking water people, lithium doesn't have an MCL, but there's a groundwater protection standard that's, I think on this one, it's really based on the up gradient wells. And so almost the same thing here for the molybdenum. And again, it's I'd just say kind of a cartoony plume there, but anyway, so we were molybdenum, again, I think is one that doesn't have an MCL, but in the federal CCR rule, they published limits, and it's 0.1 milligrams per liter. And, we're just, again, just sort of slightly above that, but enough to, to move forward with some type of remediation. So before I talk about the selection of remedy, or I guess it's kind of the lead into it, the rule has, a few public processes, and one was to have a public meeting to discuss or to highlight the potential remedies. And so we brought forth, kind of the monitored natural attenuation, which is a fairly common approach for a site like this. We looked at the pump and treat, and some of the other things like the permeable reactive barriers, things like that don't really work for the parameters of interest here. So again, we had a public meeting in Wheatland, Wyoming, and I forget the exact date. It was either sometime end of January, beginning of February. And, I don't know if we were, a little nervous about how the meeting might go. But I will tell you that there were probably four or five people from Basin Electric, 4 or 5 people that showed up from the Wyoming Department of Environmental Quality. And there was only one, what I would call civilian. One guy showed up, and he didn't have any kind of thoughts or suggestions on any kind of remedy, but he was just wondering if he could buy some bottom ash because he wanted to use it for some beneficial use. So that was kind of interesting. So we did the meeting. There's a timeline that you follow in the CCR rule, and eventually we selected source control. So that's removal of the waste and retrofit of the surface impoundment. You can see that's what is shown there. remove the waste and retrofit with a kind of prescriptive lining system. So the next part, so we've got the source controlled and no more leaks. And so the next thing is to figure out how to clean up the groundwater that's impacted. And so kind of the idea was that we could get by, or well, not get by with, but 2 or 3 extraction wells would probably do the trick. And you can see some kind of simple kind of groundwater monitoring here, kind of showing kind of particle paths to the extraction wells. And again, the idea here is that we would be able to really remedy the site in fairly short order, because recall I mentioned it's it's a bit of a sandbox out there. The aquifers and wells behave just like they should out of a textbook, so it's a really nice site to do this. Let's see here. So this is kind of same slide again, a little bit different information here. So when we got into a little bit more detailed design, the extraction rates were calculated, and they're just under 10 gallons per minute, which is pretty easy to achieve. And the treatment is, I don't know if the treatment is really just to put it back into the pond for evaporation. So we're not, obviously not destroying the lithium or molybdenum or really changing it, but it's being, transferred really from one media, from the groundwater, into an engineered surface impoundment. And then, when the plant eventually closes and is decommissioned, then that material would be excavated and managed appropriately. So the one bullet there that's a little out of date here. So contracting for implementation in 2021, there have been, I guess, numerous supply chain issues, and it's been really kind of a slow go. Back and forth with especially fine tuning the design, and kind of running that up the flagpole and getting all the approvals. But I think the extraction wells have been installed, and they've been in place for a while. But really the hardest part is the plumbing and the electrical. To get the power out there. We're at a power plant, but power to run the pumps is not just right there. Certainly not at the right voltage. There's considerations with the piping. There needs to be some heat trace. It does, get cold in Wheatland, and so we don't want the pipes to freeze up. So that was another consideration, kind of an add-on. The other thing that was interesting here is in the area of you can see the 2 blue wells, the 2 blue dots there that are the extraction wells. There is a major utility corridor that runs adjacent to the plant. So I think there's petroleum, maybe oil, and a gasoline line. There is I think a significant fiber optic communication line that runs through there. And so when we were going to do the drilling for the additional wells to characterize the nature and extent, I think there were 5 or 6 different companies out there on the locate, and really concerned about having a drill rig run around over that infrastructure, and so there were quite a few considerations. So it wasn't, I think all utility plants are probably hard places to do projects like this, but this seemed worse than usual with all of the extra underground utilities. So I guess kind of winding down here, the site really would probably be a good candidate for the monitored monitored natural attenuation. The concentrations of the kind of parameters of concern were very low. And I don't want to say that the power station is in the middle of nowhere, but it's really in the middle of nowhere. So there are no neighbors, there are no nearby receptors, and so there's really no issue, and no issue except for maybe from a regulatory standpoint to do a quicker cleanup. However, when Basin Electric looked at this, we looked at the timing of it and the cost, and surprisingly, the cost for the groundwater extraction system, it's not that much worse than monitoring for an extra 40 years or whatever it might have been, and of course the optics of it look good. You identify an issue or concern, and you're doing something to take care of it. So it was really, I think, really good that Basin was able to move forward, kind of with a remedy and with a cleanup. And here's sort of the brag on this one here. And normally we don't, highlight, the kind of the reports from ENGOs, and I can't remember which one did this, but I'll just kind of read some of the important stuff here. The Laramie River Station is one site where the remedy appears to be adequate, and it's went on to say that there was an adequate number of wells around the coal ash dumps. We don't like that. They're waste management units. And Basin Electric is planning both source control, which is the retrofit, and groundwater treatment, and is going to take care of it in a hurry. And so the infographic out of the report there is starting on the left side, that they're, they, in their estimation, there are 265 sites across the country that, appear to have some impacts from the disposal of CCRs. And then you can kind of see the breakdown that, if the utility is planning to do something or not, and depending on the next kind of middle part there is some are committed to the cleanup and some haven't made a decision. And we kind of move all the way over to the right side of the chart. And so the Laramie River Station was really the only site out of those 265 that got a passing grade. Again, and I'm confident that other utilities, their work is fine and is kind of meeting the mark of the rules. But in this one publication here, it kind of came out that the plan for Laramie River was apparently kind of special. With that, I guess I would be open to answer any questions folks may have.
Yeah, thanks, Kevin. So if you have a question, please throw it into the Q&A. I'll ask one. Kevin, was this mostly voluntary action by the company, or was the state regulatory program, I assume, involved, and to what degree? Could you sort of comment on that?
Yeah, great question. The CCR rule in general is self-implementing, and so your course is kind of charted out kind of by the requirements of the rules. And of course we did frequently meet with Wyoming DEQ to let them know what our plans were and to get feedback from them on that. And there were, again, not huge regulatory hurdles, but with the retrofit of the surface impoundment. So in all, we started with, well, there are 5 surface impoundments, and we're retrofitting all or part of 4 of the surface impoundments. So all of those retrofits had to go through the Wyoming DEQ, I guess what's called the Chapter 3 permitting process. So yeah, there was certainly interaction, and you know, kind of maybe not, well, certainly, yeah, and permits that were issued by Wyoming DEQ, and I will say that they were, you know, really good to work with, and we had some tight timelines. The one thing I didn't mention earlier is that, you know, again, the plant relies on evaporation for water balance, and so if we take a pond out of service for, you know, any amount of time for the retrofit, then we're, you know, shuffling water around between the ponds, and it, you know, gets a little bit dicey. But yeah, the Wyoming DEQ was really good to work with, and yeah, we appreciate their efforts as well.
Well, excellent, Kevin. I don't see any additional questions. So just a big thank you for taking time out of your day to be with us today and present some interesting information to us. Certainly appreciate your efforts. Thank you very much.
All right. Well, thanks very much for having me.
You bet. All right. So, Mark Mayer, are you able to hear me?
Yes, I can. Can you hear me?
Yeah, I can hear you. So for the group's knowledge, Mark is on traveling today on the road. So he's appreciate him taking the time to get in touch with us to help go through his presentation today, and grateful that he's in a spot where he's getting a little bit of cell reception so he can communicate with us. So Mark, what I will do before I introduce you is I'll throw your presentation up on the screen.
Okay.
And then I'll let you know where we're at, and I will try to guide you through that.
Yeah, I'll let you advance the slides. I'll just kind of say next slide when it's ready.
Okay. All right. Hopefully that is up, and folks are seeing that. And let me move some things here and give you a little introduction. So Mark Mayer is here today, and he's going to be talking to us about our DANR statewide lead service line inventory project. Mark is the administrator of South Dakota's drinking water program and has worked for DANR since 2003. Prior to his work for the department, Mark worked for 14 years as a consulting engineer in private practice. He's earned his Bachelor in Science and Civil Engineering from SDSU, a Master's of Science degree in Civil Engineering from the University of Kansas, and is a registered professional engineer in South Dakota. So, Mark, thanks for being here with us today. And I have you on your introductory slide right now.
Okay, and I'll have to apologize to the group for the wrong title of the conference there. This is, I'm getting a lot of mileage out of this one. So anyway, you can go ahead to the next slide. So before I jump into the lead service line project, I was going to give people a little bit of an update on kind of what's on our radar. We have right now the EPA's efforts to do the unregulated contaminant monitoring round 5, so that's UCMR 5. And those samples are going to get a little interesting. That's 29 different PFAS compounds and lithium as well. And so results for those are just starting to come in from the labs into EPA's data system, and then they have to get reviewed and approved, and ultimately they'll be starting to be published sometime probably in the next quarter. But we also are putting out our operator and system awards this month, and the annual water quality reports, or the CCR reports, as EPA calls them. We did get PFAS regulation dropped on us here a couple weeks ago, and so we're reviewing that to see what challenges that's going to present to us and systems and implementing that. And we also have a couple of WIN Act grants that we're working on for lead sampling in schools and daycares and disadvantaged community work. And then we're also keeping an eye on the lead and copper rule improvements rule that complicates the lead and copper rule revisions rule that's been published. And with that, we're going to jump into the statewide lead service line inventory project, which is something that was required under the lead and copper rule revisions that were published a couple years ago. So anyway, the lead and copper rule revisions were first published in December of 2021, and then they got pulled while Biden looked them over, and then they got republished, and so they promised this lead and copper rule improvements rule that will be changing pretty much, potentially touching everything other than the inventory. So that's why we're doing the inventories, and the inventories are to be done in what they call an early implementation process, where we don't have primacy of the rule yet, but EPA expects water systems to conduct these inventories prior to the states getting primacy. So, so that's what we're working on, and realizing the lift that would be for all the water systems that would need to do this. We felt that it was necessary to do a contract to get some support for the water systems to help them complete this. So you want to go to the next slide. So the project was broken up into 4 different phases to kind of put it into some sense of order. And the first phase, we'll go to the next slide. The first phase is what we're calling the public engagement phase, and that is where we are developing information to help water systems engage the public to collect this service line inventory information for the water system to be able to get into each of the homes that they serve and physically verify the water line in the basement or crawl space or whatever would be extremely time consuming and difficult thing to do. So we're trying to provide some tools and some messaging for the water systems to be able to consistently reach out to their customers and ask them to help by getting that physical verification of the service line material that comes into their home. And then, so that's where we're at right now. We haven't launched this yet. We're actually going to launch it tomorrow at the water seminar in Yankton. But the phase 2 of the project is going to be what we call our initial service line inventory campaign, and that's going to be just kind of a blitz effort. We're going to try to get water systems to engage with their customers and get as much information as they possibly can early on here. We will have templates for their inventory to be recorded electronically, and then we can upload that into a GIS database. And then we will also have messaging materials and different things that will help them. And then we also have a field services component that is kind of just a loose task that will be kind of on a case-by-case or system-by-system basis, depending on what kind of assistance they need. Some systems may not need any help. Other systems may need a lot of help. So we had a portion of the contract set aside, $480,000 set aside to do this field services work and help with systems. The overall contract was just under 1.5 million total. But anyway, we're going to try to get all this information in phase 2, and then phase 3. Next slide is going to be sort of a compilation of all of that material. I guess this slide, sorry, this slide just kind of gives you a sense of the resolution of the data that we're asking for. We're not trying to get real specific. These are the four different types of service line identifiers that we will be tracking. Of course, lead is the primary focus, but there's also a category called galvanized requiring replacement. Those are galvanized lines that were either lined inside with galvanized, or they were downstream from a lead gooseneck or a lead line at some point. And then we have non-lead, so that's anything other than lead, plastic, copper, all those things. And then we also have a lead status unknown, because it's reasonable to anticipate that not all service lines will be able to be identified in this initial push. So that's the last category that they can report. And then we will need physical location for each of the service lines, because that's how we'll get it out onto the GIS system. Anyway, so next slide. So phase 3 of this project is going to be basically compiling the data from phase 2, and then using that to kind of better extrapolate what the unknowns might be if we see a systems tracking 30% lead lines and they have 50% unknowns, and we're going to say the 30% remaining lines that were unknown were going to be lead as well, so that we can kind of make a better estimation of what those unknowns might be. But the bottom line is we're really trying to maximize our knowledge of how much of a lead problem we have out there. It's not known really extensively, and with the bipartisan infrastructure law money that's designating lead service line replacement as a priority, and we have a big chunk of money to do that. We're trying to maximize the use of that funding and get as much done as we can to get the lead out. But then the fourth and final phase will be after we kind of get our estimate of what's going on statewide. We're going to just keep whittling away at the final inventories, working down those unknowns, and get a complete materials inventory for each of the water systems that are subject to lead copper rule. And those are all due, according to the rule, by October 16th of 2024. So there's going to be a lot of work ahead of us, and we'll be plugging away. So in order to do that, we did advertise, put out an RFP, and sought proposals from companies or contractors to help us with this. And we did, I could go ahead and advance to the next slide. We did get 4 proposals, and the winning proposal, or the proposal that we awarded the contract to, was a team led by Bartlett West with Black and Beach, Barr Engineering, and Quick Rain Lemonly, and the members of their team. The Quick Rain Lemonly, they're a marketing company in Sioux Falls that we are working with for the messaging. I think that'll be a really advantageous thing for our systems. These folks didn't know that lead was pronounced lead. They thought maybe it was lead. And so having that level of understanding or not understanding, we feel will be helpful, because we'd have to work with them. kind of educate them on what it is we're doing. And we feel they'll be able to better connect with the typical residents of water systems that may not know a lot about what's going on in terms of lead in drinking water. So anyway, that's what Quick Grain Lemonly is. Wacom Beach is going to be kind of involved in the GIS model, and then they are also going to do some predictive modeling for some of the larger systems. We can use that initial inventory data and other databases that are out there on year built and different things like that, and they can do some modeling to determine unknowns that is shown to be very helpful and efficient. There is some validation, some field validation required of those, and the systems will be asked if we do use predictive modeling for a system, they will have to do some potholing or physical verifications of some of the unknowns in order to ensure that confidence in the model is high enough to rely on. But anyway, and then Barr Engineering is the firm that they're going to use to do a lot of the field services, where they can kind of go one-on-one with the systems to help them with the inventory work, and if somebody needs a little help on the digital side of things, maybe they can help them get started there. So anyway, that's kind of the team that we'll be working with. And go ahead, next slide. So next few slides just kind of give a little idea of some of the work that we'll be doing. Like I said, we're really focusing on public engagement and consistent messaging across South Dakota. We really want that message to get out there that this isn't a government mandate as much as an opportunity for them to know whether or not lead could potentially be impacting their health, and if it is, how they might be able to get in line to get that line replaced and help prevent that risk to their family or consumers. And so we are the bill money is tied to social equity, and so we will be looking at that in that phase 3. We'll be looking at what systems meet our disadvantage criteria definition that would allow them to qualify for some grant money as part of the bill funds. And then the focus is just the service line, not really the premise plumbing. So from the main in the street to the home, and then typically there's a break in that line. Usually it's at the curb stop and the property line, and so there's a private side of the service line and a public side of the service line, and we'll be identifying both, because sometimes the public side has been updated, the private side hasn't, and so we'll have to identify those so that we can ultimately shoot to get all the lead out of the service lines in the entire state. But again, prevalence plumbing, so the piping within the home, we're not going to go down that road, not that we know of, and so that's kind of where we're shooting for. So let's go to the next slide here. So these are just kind of shows you a distribution of the state and the water systems that will be subject to the rule. So it's truly a statewide effort and a statewide requirement. Which also underscores the need for consistent messaging. With South Dakota's connectivity between people. If grandma's hearing something different from her water system than her kids, then they're going to know that, and then the conspiracy theorists are going to come forward, and things going to unravel. So we really are trying to provide that really consistent messaging to help the systems stay, like I said, this kind of outlines the 4 stages or the 4 phases. This is part one less spin on what I just talked about previously, but so I think we can move on in the interest of time to the next slide. And here's just some stuff that we're talking about with public engagement plan. You know, there'll be infographics, there'll be templates for them to download that they could print out and add their logo and different things. So it's coming from system or customer to help them with this information. There'll be social media templates that they can use to put out on whatever social media platforms they might use. And we will have a project website out there that all of the information will be available with frequently asked questions, things like that, that we tend to be kind of a living document as we get questions that come in. A new one we'll add to the list with it. It might answer somebody else's question down the road. But again, we're really focusing on the health issues of lead and the risks of lead poisoning. And this is kind of dovetailing nicely with other efforts that the Department of Health is doing right now with blood lead levels in children. And the U.S. Health and Human Services is also focusing on the risks of lead poisoning. And so it's all kind of coming together here. Next slide, please. So this initial service line inventory campaign, there will be a smartphone app that people can scan a QR code and it'll open this little survey, and they can go down to their basement. They can ask a couple of questions or answer a couple of questions as far as you know, what it's kind of a, depending on the answer, you know, how the survey evolves. But if it's like my home was built recently and I have a plastic pipe, it's 2 questions and they're done, you know, kind of a thing. If but they have an opportunity to take a picture with their phone and they can submit that, and then that'll be the verification that we need. They can also do a scratch magnet test, those kinds of things. And so we, if they don't have a smartphone, they can do a paper version of this. And so those are the sorts of tools that we'll have. And then they'll have this dashboard that kind of shows where we're at on a statewide basis as far as numbers of service lines identified and how many of them are lead and how many are unknowns and that kind of thing. So anyway, that'll all be on that project website that I talked about that Bartlett and West will be putting together. Go ahead, next slide, please. So this is a picture of what's envisioned to be the GIS data portal that you could look and see at a home on the map and see if the dot is certain colors. It'll tell you whether it's lead or not lead, and then if the dot's split in half, it can be, you know, public side can be one material and the private side can be another. So it's a way to visualize things, and these will have, each system will have this sort of system-wide information compiled in a dashboard like this. So, and then we'll have some cost estimates for each of the systems when we get through phase 3. So, okay, next slide. And then final inventories, again, we'll be shooting for a, you know, completing all of these inventories by October 16th, 2024. And we can track them here holistically across the state, and there'll be a dashboard that will kind of help visualize that as we get through the project. And then once the final inventories are submitted, then the rule will require the system to update those inventories annually based on their lead service line replacements. You know, I think the current goal is for all lead service lines to be removed within 10 years. We'll see how that goes. I think a lot of it will depend on some of the funding and the ability to get that funding out the door. They've got some pretty tough strings attached to that money right now. We're working on trying to get them to rethink some of those for some of the smaller projects in particular. But let's go with the next slide. So here's a spreadsheet, an example of the spreadsheet that we'll be providing. It's a template. There'll be some kind of required columns that each system will have to fill out in order for it to be complete. But there are other information that they could compile while they're at it, and it would be nice for them to maybe have that operationally, but it won't be required in order to be complete for the inventory purposes. But we'll clearly identify which columns have to be filled out, and then the others will be sort of optional and, you know, for them and for their use primarily. So, and those critical things are the location, a physical address, and then, you know, whether it's lead or not lead, and or galvanized requiring replacement or unknown, that kind of. So I think the next slide is another shot of the spreadsheet stuff. We're going to try and streamline this. This is EPA's spreadsheet that was provided as part of their inventory guidance manual, but we're going to try and streamline it, kind of simplify it for small systems, especially, you know, just cut to the chase and don't get a lot of fluff in there. So that's that. That's what we got for the next slide. And that was it. So again, my name is Mark Mayer, and I'm administrator of the drinking water program. Aaron Stever is our consultant, the point of contact for Bartlett and West, and that's her contact information. The spring seminar was supposed to be in February, but it got postponed to a blizzard, and so it's actually started today, and we'll go through tomorrow noon, and that's where tomorrow morning we're rolling this out, and Aaron Stever is giving a much more thorough presentation of this. We'll be recording that. That'll copy of that recording will be available out on that project website for folks to be able to review if they missed the presentation, or if they want to review it so that they make sure they're doing the right thing. They can click on it and watch it on demand, kind of a deal. So anyway, that's a real quick overview of the project, and I guess that with that I can field any questions.
Sure. Yeah, thanks, Mark. So if you have a question, please use the Q&A button and put it in that Q&A. Mark, I guess I'll ask a question as a person who lives in a water system. What should the expectations of the resident be in terms of what they would have to do? You talked a little bit about the app and doing that. And is there a voluntary participation, or how does that work?
Well, it definitely will be voluntary, but we're going to try to make it enticing enough that you would want to do it through curiosity and you know, protecting your health and that of your family, I guess. What it'll take a individual homeowner, probably less than 5 minutes, to you know, just go down and take a quick look at where the water line comes into their house and try to identify it as lead or not lead. And you know, the app is one way to do that, or if they don't have a smartphone or whatever, they can do it other ways. But just getting that information to the water system will save the water system a ton of time, which ultimately, you know, frees those operators up to, you know, do what you want them to be doing, just producing safe water and not, you know, running around looking at everybody's line coming into the basin. So, and then that'll keep your rates lower, because if they have to do it all, then they'll either have to hire another person to kind of help get it done, or they'll have you know, they'll be taking away from their other duties.
All right. Well, Mark, I am not seeing any questions, but I certainly
Okay.
appreciate you taking time out of your travel to give us this info. It's good info, and I know that there'll be more to come. So, you know, pay attention to
Yep.
DANR's social media and your water systems, and we'll continue to work through the process.
Yeah.
So, Mark, travel safe, and thanks so much.
Okay. You betcha. Take care.
Bye-bye.
Bye.
All right. Thanks, Mark, for that. Next up on our list today are Jackie and Megan. Jackie and Megan, are you on the line?
Yeah, I'm here, Brian.
Awesome.
Yeah, I'm here. Can you hear me?
Yes, Megan, we
Okay,
can.
perfect. I was having
Awesome.
some Zoom computer issues. So
Yeah, so I was too at about 1:15. It was kind of freaking me out. So
yeah.
I can sympathize. Before I give you folks your introduction, Megan, I did want to apologize. We had your last name spelled wrong on a couple of our documents, and that is our bad. So sorry about that, and we'll work on doing that right the next time. So appreciate your understanding. So Megan and Jackie are here with us today to speak a little bit about the states and the EPA's regulatory response to a mercury spill that occurred in Lead, South Dakota this past December. So Megan is a federal on-scene coordinator, OSC in EPA Region 8. She began her career as an OSC in Region 7 in 2008. She has a BS in medical engineering from St. Louis University and a MS in engineering management from Missouri University of Science and Technology. She's been a lead OSC on a number of removal actions in both Region 7 and Region 8. She also has response experience and leadership roles in many different environmental responses, including the Deepwater Horizon, the 2011 Joplin tornado, Hurricane Harvey, Hurricane Maria, Typhoon Yuta, the 2019 Nebraska floods, and California fires. She enjoys exploring the mountain regions and learning the ins and outs of the world. Is passionate about running, hiking, and yoga in her spare time. And joining Megan today is Jackie McGuire from DANR. Jackie is originally from Wisconsin and graduated from the University of Wisconsin-Madison with a BS degree in genetics and zoology. She's previously worked for other state and federal agencies as fisheries and laboratory technicians, and she currently works for DANR as an environmental scientist in the spills section of the Inspection, Compliance, and Remediation Program. Welcome to you both. Thank you for being here, and I will turn the reins over to you.
All right, thanks, Brian. Let me get my screen shared. Can you see it?
Yes.
I see it, Jackie. Yep.
Yeah, I can see it too. I had my mute on. And I was struggling to find it as always. Yep, you're up.
All right, well, thanks for that introduction, Brian. I'm Jackie McGuire, so I'm going to start off today's talk with how the state first heard about the mercury release, and then I'm going to let Megan take over to explain EPA's response and cleanup operations. So, I'm trying to get my PowerPoint to work now. Okay, there we go. So the Department of Agriculture and Natural Resources Air Quality Program received an interesting call on Monday, December 12th of last year. The call came from the Lead Deadwood School District nurse, and she reported that a student had brought in an ounce or so of mercury to the school that day, but she also suspected that there was more in the student's home. And the main thing is she was looking for help with disposal of the mercury and for testing the home. There was no mention of an actual release of mercury, merely that the student had some and likely had more. So that information then ended up trickled down to the spills program. And initially, I just assumed that this was some sort of household source, like an old thermometer. And so I coordinated with our hazardous waste staff, who provide a list of disposal companies and any potential contractors that could test the air quality in the home. And then I spoke with our pesticide disposal group, since they've helped us out in the past with disposal of some of our more hazardous items. And I left a voicemail with the nurse wanting her to call me back so I could pass on that information. So it wasn't until, so at the end of that day, I kind of thought, we don't really have a spill. This is a nice, easy issue, easy to handle. We'll just get some disposal company out there. We'll be good to go. But the next day she called me back and I was able to interview her to gather some additional information. And she mentioned that the student had actually brought in a 20-ounce jar of mercury to the school and took it into the art class. And several students took it out of the jar, poured it onto a table. Some of it rolled on the floor. The custodian there was able to clean it up, and she didn't think the school needed extra cleaning. But she also mentioned that she had been in touch with the lead fire department, who had then sent Rapid City's hazmat team to investigate the house and lead. And she said the hazmat team was able to work with the mom of the household and help them dispose of any of that remaining mercury. Well, based off of this information, I knew we officially had a release of mercury, and this was not just your average thermometer that would normally maybe contain 1/4 of an ounce of mercury. This release was potentially much larger. And given that this was in lead, we were assuming that this came from a former employee of the home state mine. So we contacted the director of maintenance to learn a little bit more about the incident at the school. And they did confirm that there had been a release at the school, but they dealt with minor mercury releases before. So they were aware. They used an eyedropper to pick up the droplets. They knew not to use a vacuum to clean it up. All that's really good news, but our department is also familiar with mercury releases, and we know that they can be extremely difficult to fully clean up, even if you're careful. So then my next step was contacting the Rapid City hazmat team and see if there was actually a release in the home as well. And they sent in a report, and based on the findings of that, we were stunned. So the team found 3 empty glass bottles that were used to store the mercury. You can see them on the screen in the background, and notice there's kind of different dark lines indicating the levels in the bottle. And on the right side, that's a picture of the rug that they found in the bedroom, and you can see significant beading visible, and that rug was in the child's bedroom. So the hazmat team, they didn't have the equipment capable to get any accurate readings of the mercury levels in the home, but they were able to provide helpful information to the mom. They advised her to keep the child out of the room, ventilate it if possible, and they did remove 2 rugs from the home, but they were only placed outside. The hazmat team was also able to interview the family and just learn a little bit more about kind of how this all got started. So to break everything down, combine all of our interviews with our department, we kind of put together a picture of what happened. So we're assuming starting maybe around December 9th, potentially earlier, that the 14-year-old found some jars containing mercury among his grandfather's old homestake mine memorabilia in the house. And like any curious kid, he played with it in his room and performed all sorts of experiments with it. At one point, he even stuck it in the freezer to see what would happen. And on Monday, the student brought one of those jars of mercury to school. Students began passing it around in homeroom, and they even got some condiment containers that they found from the cafeteria. And they filled all those little containers up and passed them all around everybody all throughout the day. We know they played around with it in the art room, but they also went all over the school with it. It was stuck to students' hands. They tried to wash it off in the bathrooms, on their clothes. These rolled off onto the floor and, gets on their shoes. They tracked it everywhere through the hallways. So even though staff was able to clean up the art room where it was mostly played with, it was still everywhere. As I mentioned earlier than that day, the nurse had contacted the volunteer fire department, and the Rapid City hazmat team came that night. And if anybody remembers, back December 12th of last year, that was also the night that we started a week-long blizzard across the state. So good collision of events going on. So then the next day on Tuesday, our department was in contact with all those affected parties, figuring out all this information. And based off of that hazmat report at the house and everything we've learned, our department was extremely concerned about the health and safety of the family in that home. We were also concerned that the school might not have been adequately cleaned up for the safety of those students. Just based on the size of that school alone, you can see in that picture, it's quite a large building. So based on those concerns, we requested assistance from EPA to assess both places and clean them if necessary. We did receive permission from both the mom and from the school superintendent prior to asking for EPA's help. Now, due to the blizzard that was going on, EPA and their response contractors had a little bit of difficulties getting into town. We had a lot of road closures. They were able to make it in on Thursday. And then EPA was able to escort the family out of the home into a nearby motel. And then the START contractor was able to begin assessing both the home and the school that day. So with that timeline breakdown and information, I'm going to head it over to Megan, who can let us in on the details of what EPA and the contractors were able to do.
Yeah, thanks, Jackie. So I guess just real quick, I work for Region 8 out of Denver. So like Jackie had mentioned, I was not the initial responder on this. It was my coworker, but kind of the size of the spill, we needed an additional person on site. So my coworker had actually gotten there Thursday. I came in on Sunday. We actually overlapped because this ended up running into the new year. So I was there for about 2.5 weeks. I'll kind of go into the timeline of that. But just real quick, this is just kind of the front page of our National Elemental Mercury Response Guidebook, which is basically what it says, kind of our guidance for cleaning up spills. Next slide. So I put this on here. It's a lot of information, but kind of the big thing here, and this is in the guidebook, but it's actually from the Agency for Toxic Substances and Disease Registry, ATSDR, which is the federal agency that deals with human health risk with exposure to hazardous substance. So EPA does not make health determinations, but these levels come from guidance from ATSDR. So the levels that we are looking at for residential settings is less than 1,000 nanograms per meters cubed is, like it says, acceptable level for normal occupancy for most sensitive persons. So, the elderly, children. And then like the 3,000 to 6,000 is kind of the level we use for vehicles. And then also to allow personal belongings to remain in the owner's possession. Greater than 10,000 is basically kind of our recommended evacuation level. So next slide. So then this is the suggested levels. Can you go back? That was a different, yeah, sorry, thanks. Suggested action levels for other locations. So this is, kind of for businesses, but then acceptable level for schools to resume normal operations. We always want to, get the level as low as we can, but it's 1,000 to 3,000 vehicles is on here again, and then the same with the 10,000 level. Kind of the basis of this is you're, at work for 8 hours as opposed to, you might be at your residence for 24 hours, kind of the background behind that. So for kind of the summary for this, for the school, we're looking at less than 3,000, and for the residents, less than 1,000 post cleanup. Next slide. So like Jackie said, assistance was requested on December 13th, but because of the blizzard, the EPA responder was not able to make it there until December 15th. And our contractor went in there, and the picture kind of on the right, Jackie had it up on one of her slides too. It's a drone, it's a mercury vapor analyzer. But in the breathing zone throughout the residence, the numbers were consistently above 20,000 nanograms per meters cubed. The analyzer is actually showing in micrograms there, but then some household items exceeded 100,000 nanograms per meters cubed. So, I mean, it's 100,000 greater, than our healthy, occupancy cleanup level. And on December 17th, the residents at the home gave EPA written access to perform a removal action. And I don't have a lot of pictures of the home. I'm glad Jackie had the pictures of the vials and then the close-up of the carpet, because I did not put that in here, but people's homes get, very sensitive. Also, kind of the background behind this home is it was kind of a generational hoarder situation. So there was, hence the child finding his, Mercury from his grandfather up in the attic. A lot of items in here. Jackie kind of gave the timeline. We were looking at December 9th when the child reported he played with it. During our cleanup, we think it probably was a lot longer than that, but I've been doing this job since 2008, and I've done quite a few Mercury cleanups, but this was by far the worst one I've ever done. Not in the amount of mercury spilled, but just the extent. The child was throwing it around the house. Like pictures of the bunk bed, beads were, stuck to the side of the bunk bed to the metal there. So, yeah. So next slide. So after we got written access from the property owner, we cleaned the residents up, and I'll go into this in a second, but kind of concurrently while cleaning up the school. But the residents took us from December 13th. We arrived on site on the 15th until January 2nd to clean that residence up. That involved removal of personal belongings from the residents. Again, this was a very difficult situation. A lot of times we try to decontaminate things. In this case, there were so many items. Everything was just heavily contaminated with mercury, that we really were unable to save most things. So normally it's a lot more localized. This spill was through the entire downstairs of the house, like in all the bedrooms, corners of flooring, carpets, that sort of thing. So, there's the mercury guidance, but kind of dependent on the situation where, a lot of times we save things that have come in contact with mercury. In this case, pretty much everything had. So we requested that the property owner, one, give us permission to, dispose of things. We have to have that permission. But instead of, kind of making a list of everything, giving us a list of what the property owner really wanted to keep so that we can kind of focus our efforts on that. Processing potentially salvageable items by heating and venting. I will show a picture of that here in a second. Use merc racks to collect elemental mercury beads. That's a special vacuum, obviously to collect mercury, but basically vacuuming mercury with a regular vacuum is kind of the worst thing you can do. It revaporizes it. Heating and venting the residence, kind of the number one thing we do for cleanup. Applying Merc-X to the flooring and other hard surfaces. It's powder that's mixed with water, and it basically binds the mercury to suppress the vapors. And then we also applied epoxy to the flooring. Next slide. So like I said, I don't have a lot of pictures of, the property itself, because we kind of tried not to take a lot, since it's kind of sensitive information. But on the left-hand side there, you can see those are bags of the personal items that the property owners wanted to keep. So basically what we do is we heat those things in the bag to kind of release those vapors, and then using the mercury vapor analyzer, kind of take the headspace to see what readings we're getting for those personal items to determine whether, they need to be thrown out or continue to be heated and vented, wiped down, or if they can be kept. And then on the right-hand side is just a photo of heating and venting the home. Like Jackie said, there was the blizzard, but then after the blizzard, it got colder and colder and colder. So while we were working this, it was like below 20 for 3 or 4 days straight, which caused us some huge issues. Again, heating and venting items is basically the best way to clean up mercury. So, if this would have happened in the summer, the cleanup would have gone a lot faster. The other thing is, to kind of heat and vent these items, we have to use a generator. Well, when, diesel gels up in the cold, we couldn't basically heat and vent items for 4 or 5 days, which kind of put us behind as well. Next slide. So when we did complete the cleanup, which I kind of went through that, but basically we had to move all the items out, dispose of, I think we ended up with 4 roll-off boxes of things to dispose of. And the house was basically empty, but we use our Lumex, which is one of the mercury vapor analyzers, to do an 8-hour average sampling. We run it for 8 hours and it collects 8-hour samples. So this is just kind of our final clearance graph. We did this on January 3rd when our levels were consistently lower. And you can see it always starts out a little bit higher, but everything was below 1,000, which we were really excited about. We basically, the amount of items and all the carpet and everything was so heavily contaminated that by removing that lowered the levels a lot. So something else that we can't do is we cannot replace things. We have to leave the home the words habitable. So Jackie had mentioned the child had put it in the freezer. Based on readings, the child definitely had put it in the freezer. So we did replace the fridge, but a lot of the other items, we provided a list of, the more expensive items that were thrown out for the property owner to submit to their insurance, but that's something that EPA cannot replace, unfortunately. But again, we also don't dispose of anything without the property owner's permission. So if there was something on that list the property owner wanted to keep, I would give her a call and, kind of discuss it. So next slide. And so the high school. So these were kind of run concurrently. Jackie, had told the story. We've gotten kind of different stories, and we've gotten, after doing some other screenings and talking to other students, that they were carrying the mercury around in like those paper ketchup containers. But on December 15th, we also did initial screening at the high school. And here for the high school, we're looking at that 3,000 level. So we had 3 classrooms that exceeded 10,000 nanograms per meters cubed. Our highest reading was 95,000. It was either in the chemistry room or the art room off the top of my head. December 16th, the school district gave us written access to perform a removal action. And then from December 17th through the 21st, our contractors determined the extent of contamination. So that 15th was just kind of the initial assessment. But this high school was built for almost 1,000 students. And they're currently like around 200 there, but a very, very large school. Tried to get some information from the children about, which classrooms was it in. It was a group of freshman students, so we knew kind of like which lockers it might have been in, that sort of thing. So to kind of determine this extent of contamination, we kind of divided the school up in 91 areas total. 30 areas were greater than 3,000 nanograms per meters cubed, our action level. And then we had 7 areas where elemental mercury beads were visually observed. We called those highly impacted areas. And I see I missed a parentheses there, so I apologize for that. But basically the chem room, the math room, the art room, a boys' bathroom, a welding shop, which we ended up getting that information over a week after we had started the cleanup, and a couple of other areas. Next slide. So I don't know if everybody's on their computers, so they may be hard to see, but on the right-hand side there, you can see that bead just to the left of that table leg. Yep. And then on the left-hand side is another picture. That picture on the right, and the picture in the center is just our contractor screening. But actually that was the art room. That was one of the, highest contaminated areas. And since it's an art room, you can imagine, I mean, there's glitter all over the floor. Like, it's really, really even hard to see these beads. Next slide. So the high school mercury removal activities, the cleanup took from December 17th until December 30th. The school was closed to all students during the cleanup. Like Jackie had mentioned, there had been the blizzard the week before. And then the school had been closed due to the blizzard. We had gotten this information over the weekend. There were 2.5 days before winter break. And we ended up, the school district superintendent actually ended up closing the school for those days before winter break. So he wasn't happy about it. It was actually EPA's recommendation though. So that is a school district decision. EPA cannot evacuate people. EPA cannot shut down schools, anything like that. That either can only be done by the school district, or, if there was like a local health department, which in this case, it actually, there is not a county health department, it actually goes to the state health department. But we did the same basic removal activities like I had listed as the residents cleanup. And like I mentioned, the size of the school was a challenge. But yeah, just a lot of, physical pickup with the Merc vac, heating and venting, which, like I said, was very difficult. We actually had a contractor leave a window open, so we ended up having to pay for some new plumbing in the bathroom, in the boys' bathroom at the school. But yeah, eventually we, let's see, next slide actually. So these are just some pictures of the work we did. On the left-hand side, you can see our contractors cleaning up with the Merc vac in the middle, and on the right-hand side, that's where we're using that Merc X to clean floors and other solid items. Next slide. And so we had to do our clearance monitoring a little differently than we do with the residents. And the residents, we had set a mercury vapor analyzer to run for that 8-hour clearance sampling in the middle of the house, and then also on the second floor of the house. We usually try to pick a centralized area that is the most contaminated. In this case, I mean, there were just so many classrooms, so many different areas. So we decided to do that 8-hour clearance monitoring with the mercury vapor analyzer in the 7 highly impacted areas that I had mentioned before. And December 27th through 30th, we went with the Lumex to all 91 of these areas and did 1 minute monitoring in the breathing zone. And at the end of all that, all our concentrations were less than the action level of 3,000 nanograms per meters cubed. So the school was basically say able to open after break, but yeah, based on those levels, you know, kind of recommended that it was okay. Next slide. We also did some screening at other residences, which I'll get into here in a second, but in the Lee Deadwood School District, the middle school is actually right next to the high school. Teachers go back and forth. The middle school students actually eat lunch at the high school. So there had been concerns that, well, I had talked with Jackie and Trish with South Dakota about it, but state of South Dakota, EPA, and then it was also brought to my attention by several parents who were concerned that this mercury may have been tracked elsewhere, you know, may have been brought elsewhere. So talking to the school district gave us certain access to screen the middle school, the elementary school, and the school buses. And we actually did screen all those areas on December 24th, and all the vapor levels were below 1,000 nanograms per meters cubed. So that was definitely good news for us. Next slide. So this is just a screenshot of our website that we use to put out public messaging. It's actually epa.response.gov. But this is just kind of a screenshot of the main page of that website. Next slide. This is what we used. We would update this daily as we were working on the school. So daily we had a site update where, you know, we said how many rooms have been cleared. This is actually the final photo on the website. As you can see the picture, the school is extremely large, and it is even larger than it looks. So next slide. And then this is also what we had on our website. So we just had the safety message and incident overview, and talking to the state, and you know, kind of the area. One of the, like Jackie mentioned, you know, this is a mining community. And so we had a lot of people that were very concerned about mercury, and other people that didn't think it was such a big deal. But we were concerned that a lot of people, you know, maybe had mercury in their houses. Also, the school nurse had contacted 16 students that were, she was told had, you know, been directly, you know, playing with this mercury, touching it. So kind of at the state's request, at the community's request, and something that we normally do anyway, is to screen areas that we think it might have been tracked, you know, homes of children that had been in contact with it, teachers that had been in contact with it. So we put that on here. We had a Google hotline number to sign up for home screening. And then we also, as you can see there, we offered free mercury disposal while, you know, our team up there was mobilized at no cost. Next slide. So this is just kind of what I was going through, but we set up the hotline number on December 17th. And then we also, between December 18th and December 23rd, we received requests for residential screening at 12 additional properties. Kind of like I mentioned, there were 16 children that we know had been in contact with it. So unfortunately, it was not all of those that we, you know, kind of knew about. Unfortunately, we can just offer it. We can't, you know, force people to have their home screened. Mercury vapor was detected in all 12 residences, and 4 properties required removal of contaminated personal items. At one property, we had to clean out a dresser, dispose of a rug, dispose of some clothing. A couple of the other ones, backpacks. There was a child that had a vial in his backpack. Maybe shoes at another. I didn't do the first one, so I apologize. Next slide. So this was kind of our surprise one, but we're happy that this happened. So like I said, we had that hotline number. Kind of one of the struggles was doing this, during the holidays. So we kind of had an idea, because I think Monday was Christmas and Monday was also New Year's. And so we kind of suspected that Tuesday the 3rd, we might, get some calls as people come back to work. And sure enough, we did. So we had gotten a call on our hotline. And it was a chemistry teacher at Spearfish High School, which is about 20 minutes away. And luckily I was actually shipping something. So I had already been in Spearfish at the time. But she had requested that we pick up and dispose of elemental mercury at the high school there. So my contractors met me there, and it was surprisingly more than we thought. She's like, oh, I think there might be a little bit at the middle school. Also, we picked up about 3 to 4 pounds from the high school. There's about 30 mercury thermometers, and then 2 separate vials you can't see because they're in those containers. But and there was another pound at the at the middle school. So yeah, we ended up picking up 4 to 5 pounds of mercury. And we're very happy we did. So hopefully we don't have to clean it up in the future. The chemistry teacher actually wasn't that happy to have us pick it up. She said she really likes having it and showing the kids, but after what happened at Lee Deadwood, she decided it was probably the best decision to get rid of it. So yeah, so this was great for us, to pick up. We've been talking to the state, trying to figure out hopefully like a way in the future that we can do more collection events in the future. Next slide. Jackie, do you want to talk about this?
Sure, yeah. So we just wanted to kind of put together a list of some of the challenges that we face just working together with, the state and EPA had. So as we mentioned throughout this talk, this was during a blizzard. This was also over the holidays. Megan was so kind to come and spend her Christmas and New Year's out here, which is not something that anybody wants to have to do. But yeah, so that blizzard made things difficult to get to the site. It made it difficult even just getting cars and vehicles around. They dug out the homeowner's car so that she would have access to her own car. Just, having the city coordinate to make sure that they got the plows to that street first. Little things like that all added together with the community working together on this. It was a huge hurdle for us. It was a big communication challenge. Sometimes we were working remotely, and that it always just slows things down a little bit. Our department's job was mostly we were in communication with EPA every day, multiple times a day, and we wanted to make sure that everyone up the chain, all the way up to the governor, was aware of what was going on over in LEAD with the cleanup actions. We also looped in Department of Education, Department of Health. We just want to make sure everybody was aware. We were so afraid that this was going to blow up into something bigger. And the interesting thing was, because there was a blizzard going on this entire time, most of the news was focused on the blizzard. So we actually didn't have any sort of a media problem. But, as Megan kind of alluded to earlier, this was a very unique situation with it being in a mining community. And normally when you have a large cleanup action like this, your biggest thing is you don't want to cause a panic to the public. You want to be able to kind of make sure that people are aware of the situation, make sure that they know that it's being handled appropriately. This was interesting because we wanted to make sure that people were aware that there was a problem and that they had a resource to call. They had that hotline number. And instead, most individuals in that community, they're familiar with mercury. They've got relatives who worked in the mine who are familiar with it, who probably had the safety training to handle that mercury, and never imagined their grandchildren handling it and taking it all over the place. But so that was, it's it's a very different kind of a situation when you're trying to actually cause more of an awareness to people. So that was challenging. The other thing is, as Megan had mentioned, authority, the Department of Agriculture and Natural Resources, we've got limited authority when it comes to, we can't close down a school. So, and neither can EPA. We can't ask people to evacuate. We can make suggestions and recommendations. And so our biggest thing was communicating with all of those other parties so that we could have everybody get on the same page and make sure that we were doing what was safest for all of the affected parties. Anything else to add, Megan?
I don't think so. It was just really, like I said, the combination of the holidays, the blizzard, and then just the cold weather. I actually had the superintendent ask me, why is this taking so long? And I said, the weather has been a huge challenge for us. If this cleanup had happened in the middle of August, we'd be able to put things outside, have them heat and vent out there. So it definitely did not do us any favors to do it in negative 25-degree weather. So it took a while. It was difficult, but we're really happy that ultimately we were able to get those levels down to where they needed to be. I saw there was a question. Or Brian, do you want me to
Sure, I can read them.
look at them?
Yeah, we'll take
Okay.
2 quick questions here. So one was Mercury hazard or health information provided to the students to their families?
Absolutely. So the school nurse that had actually contacted Jackie at the state and Trish, had talked to these families, had recommended that students get tested, get blood tested for mercury. The residents, I know, did get blood tested and were in consultation with their doctor, and then so the nurse provided it, and then like I said, we had provided it, on our website there. So if you kind of dig into it, we have fact sheets, that same information that I presented about kind of the cleanup levels, that sort of thing. So.
Excellent. And then quickly, how and where was that contaminated material disposed of?
So the roll-off boxes of material, we can, as long as there, aren't beads of mercury on things, that sort of thing. So we collect, elemental mercury with that Merc fac, and we keep that separate from the items we were disposing of. So items that we are disposing of, they actually went to Rapid City landfill. We have to do a TCLP test, toxic characteristic leaching procedure. I think that's what the sample is, basically, to prove that the levels aren't, that we can throw them away at a regular landfill. But that elemental mercury we actually disposed of. There's a place called Bethlehem Apparatus in Pennsylvania that we usually send that to. So, but yeah.
Well, excellent. Thank you both, Jackie and Megan, for that great presentation. That was certainly an interesting case and an interesting process and an interesting timing. So appreciate your willingness to educate us today. Thank you so much.
Thank you.
All right.
Yeah.
With that, we will continue through the agenda here this afternoon. Erik and Hilary, are you on the line?
Yes, we are.
Yeah.
Good, great. Thank you for being here. Our next speakers this afternoon are Erik Gessert and Hilary Clifton. They will be talking with us about a petroleum hydrocarbon release discovered during a limited site investigation and how the initial investigation necessitated additional assessment and the need to further define the conceptual site model. Erik is a senior remediation engineer for Terracon's Denver office with over 20 years of professional experience in successfully managing remediation projects. Erik's primary responsibilities include leadership, technical evaluation, senior project management, and high quality review and quality review, and he is a subject matter expert for Terracon on the topics of LNAPL, site management, and high resolution site characterization. Prior to joining Terracon in February 2018, Erik was a supervisor and technical lead for the Colorado Division of Oil and Public Safety remediation team, where he was responsible for the identification, development, and implementation of major project initiatives. During his time with OPS, Erik was responsible for the successful implementation of enhanced risk-based closure criteria for the program, the implementation of recognized environmental professional program, and development of OPS's web-based petroleum remediation guidance. Joining Erik will be Hilary Clifton. Hilary is an environmental department manager for Terracon's North Dakota office with over 10 years of experience in the environmental consulting industry across North America. Her responsibilities include project planning, scope, development, and implementation, project oversight, safety, project quality, report preparation, and client relations. Clifton spearheads project communication related to status and timely completion. Her experiences include due diligence, widespread contamination, delineation, soil and groundwater remediation, regulated materials identification, including asbestos and lead paint, and industrial hygiene services. Welcome, Erik and Hilary, and please take it away.
Great. Thank you, Brian. I want to make sure that you can see the right presentation screen.
So I do see the full-size slide on my screen. It says using HRSC to rapidly assess LNAPL distribution, optimizing
Perfect.
well placement. Okay, we're good.
Yep. All right. Brian was getting in my introduction. The title of our presentation is utilizing high resolution site characterization to rapidly assess LNAPL, light non-aqueous phase liquid distribution, optimize well placement, and accelerate remedial design. And I have to say that in my career, I've assessed a lot of petroleum sites, but this scope of work was sort of a dream scope of work to me, in that when I became involved with the project, we understood that we had an appreciable petroleum release on our hands, but we didn't have a lot of historic infrastructure associated with the assessment of that release. And so the question was, what are we going to do next? Over the course of the presentation, these are the four kind of broad categories that we're going to cover. Site history, including previous assessment activities, our approach for this phase of the project, and the characteristics and interpretation based on the assessment that we performed, followed by kind of where we are now and where we're going next. So with that, I'm going to turn it over to Hilary to get into the site history.
Thanks, Erik. So the site we'll be talking about today is located in a small community in rural North Dakota. The site itself was developed in the late 1940s, and buildings consistent with the present day construction were built in the late 1950s. And historically, it has operated as a filling and service station. This particular site was purchased by our client in 2000, and it was operated as a filling station until it was closed in 2019. And that closure was prompted by worker complaints of fumes and fuel odors and vapors within the building, and just general overall poor indoor air quality. Those complaints were filed with the state, and the state, as a result, requested a full delineation of the site. And that was when Terracon became involved in the site and with this client. So in those early discussions, the client detailed that historic USTs were reportedly removed from this site in the late 1980s. Details related to the closure and removal of those tanks weren't readily available. And we also saw a very sparse report of a spill from an ASP that was reported in 1987 of approximately 2,800 gallons. But details related to the quantities of soil that were reportedly excavated and disposed of were also not available. And our client also expressed concern related to a hoist in the service bay that's located in the middle of that building, and a 10 to 30 gallon hydraulic tank that was associated with it that he believed to be leaking. And as Erik stated before, we haven't done a phase 1 on this site. Our general knowledge of the site history is pretty limited to the few minimal documents that are available. And our scope of work, our first scope of work, was to develop a limited site investigation in response to the correspondence that our client received from the regulatory agency. We focused the LSI on those areas of concern that were identified in those early conversations. And the objective was to evaluate for the presence or absence of petroleum compounds. We also sampled for RCRA metals and PCBs on the site, but for the purpose of this presentation, we're going to focus predominantly on the GRO and the DRO. We advanced 10 borings. We converted all of those borings to temporary monitoring wells, and we confirmed that there is definitely a petroleum issue at the site in both soil and groundwater. And we were unable to delineate those impacts in any direction. So we wrote a report, we submitted that to the regulatory agency for review. They came back and said, we need more data. We want you to delineate the site, go back, do some more work. So we did. We remobilized to the site in 2021. We advanced 17 more borings. We converted 11 of those into permanent monitoring wells. And that was when we identified LNAPL in multiple wells in the general vicinity of that former USP basin. The thicknesses were pretty alarming. We had pretty significant impacts to at least 10 feet below the ground surface. As part of that assessment, we also collected subslab soil vapor samples from the basement of the building that reported VOCs above EPA visuals, and we still weren't delineated. We wrote our summary site assessment report. We submitted it to the state, and at this point, the team that was working on this project realized that this site was likely going to require some sort of significant remedial effort. And at that point, we reached out to Erik to get him involved because that is his area of expertise. The state reviewed our report from December of 2021, and their response was, we'd like to see a work plan with specific approaches to delineating the site. We want to see where you're going to investigate. We want boring locations. We think that LNAPL recovery is likely going to be required. We want you to further evaluate those vapor issues inside the building. You need to go back out and do more work. And at that point, Erik had proposed using the high resolution approach to this site. And we got together as a team and started developing a work plan, keeping in mind the goals of the three major players in this property. The client's main goal is to address the impacts on the site and sell the property. They want to move on to bigger and better things. The regulators' goals are to get a full delineation and understanding of what's going on at the site and protect human health and the environment. And our goal as the consultant was to develop that understanding of the site and the conditions within a reasonable timeframe and budget to satisfy those two other stakeholders. And so at this point, I'll turn it over to Erik to walk you guys through what we completed.
Sure. So to sort of re-summarize or quickly summarize where we were at when I got involved with Hilary and the project team, we knew that it was apparent that there were multiple releases, multiple sources over the years. It was apparent that those releases were made up of multiple fuel types. The in-well measured LNAPL thickness was alarming and obviously prompted the response that recovery of fuel in the subsurface was going to be required. The indoor air vapor intrusion concern, that's really what sort of started this chain of events when there was the notification of fumes in the building. Our subslab soil gas assessment confirmed that. And then the lack of contaminant of concern definition in soil, groundwater, and also establishment of where mobile product was. So we kind of identified those issues over 2 years worth of conventional assessment approaches. But what we really wanted to consider was, could we implement the triad approach to more rapidly enhance our understanding of the site, develop a conceptual site model for the site, and getting to what are we going to do about it a bit more quickly. briefly, I don't know if this is a review for a lot of the audience, but the pillars of the triad approach are systematic planning, which is really coming up with a goal for the project team and having that collective understanding, enactment of dynamic work strategies, being nimble in how we implement our field assessments to really achieve the goal that we're trying to achieve. And that is done through real-time data measurement, which to us means both utilizing technology that provides near instant feedback, but then also setting up a communication protocol of sorts of how are we going to share this information to the participants that need to be able to make decisions, again, so that we can achieve our goal. Those three pillars really focus on reducing uncertainty associated with the project and with the issues that we have. Here is sort of the multi-phase approach and really the compressed timeline that we came up with. Now, I want to identify on this slide that we have not performed all of the activities that we recommended here. As the previous presentation identified, it got really cold in December. That was a part of our determination to cease activity. Also, a part of it was certain things that we proposed maybe weren't as necessary as they seemed based on our understanding of how things progressed. I will say that this scope of work was met with some skepticism, both internally and externally. Internally, how are we going to achieve this rapidly? Externally, this is a more expensive approach. We had to share information on the more quickly we understand things, we're gonna save a lot of money on the back end because we're gonna introduce the right technologies to address the issues. A rapid understanding also doesn't lead in those years of monitoring that oftentimes accompany a large release. So we were able to get agreement with the stakeholders to proceed with this approach. Before we really get into the execution, I wanted to identify the pre-planning that is necessary to execute this. As Brian identified, I previously had worked at the Division of Oil and Public Safety in Colorado, and I was a big advocate of HRSC approaches, but oftentimes I just saw the vendor report as Appendix D of the consultant report, and there wasn't a lot of description to it. And one of the reasons that we felt it was really important to have some pre-planning associated with this was we wanted to establish a strong partnership. We wanted to establish what the roles were of the team that was going to be implementing thing. We worked with Dakota Technologies, which is out of North Dakota, one of the innovators and pioneers of doing this form of subsurface assessment. We determined between Dakota and Terracon, how are we going to transmit data? How are we going to capture the XYZ data that we needed to capture? And over the course of our 5-day assessment, we had morning field calls where we would be reviewing a 3-dimensional model of the information that was captured the day before. And this is where that dynamic, nimble approach really comes into place. We were able to take what we gathered, the day before, analyze it the evening of, make determinations on it the next morning. I wanted to give a quick overview of the technology that we used. The 5-day assessment was primarily 3 days. We're utilizing UVOST, which is a form of identifying where NAPL is within pore space in the formation. Those were the first 3 days. The last 2 days were a combination of membrane interface probe, which really we used to identify the boundaries of dissolved phase distribution in the subsurface. And also we did a handful of correlation sampling. The data that's generated from a high resolution approach is more qualitative in nature. So we do want to get quantitative data to support it. Briefly, you know, the UVO system is designed with ultraviolet and visible light sources, which induce a fluorescence on pH constituents contained in the majority of LNAPLs. This fluorescence is measured as the percentage of fluorescent area in the image, which helps qualify the magnitude and location of LNAPL in the subsurface. The two visuals that I have here, these are essentially what we were looking at on the daily basis and what we were inputting into the three-dimensional model that we are developing. I wanted to highlight, you know, one, the colors. The colors mean something. You know, they're not just different colors for no reason at all. They're actually representative of the different waveforms that are being picked up through the image capturing process. And then the magnitude, so the x-axis here is the magnitude of the response that we're seeing. So we get, you know, location, we get magnitude, and then we have this color, which is going to help us sort of unpack, well, what kind of products are they? How do they relate to the potential sources that we have? So now I'm going to run through a video, which should come off swimmingly, I'm sure. But this is a 1-minute video of the 3-day UVOST assessment that we performed. Overall, there were 32 locations that we did. I'm just going to start the video now. We started with a east-west transect along the front of the building. You can kind of see that three-dimensional model in the lower left-hand side. Well, by day 2, we started to get a sense of the boundary extents of the NAPL distribution. And we're also seeing vertically, you know, where did it align? That helps inform us maybe where it came from, but also where it resides is dependent on the subsurface formation. And we're going to get into that shortly. We did assess across the street. As you can see, that there are 4 borings across the street there, to the north, to the east, and to the west. And so over the course of the 3 days, we largely identified that the NAPL body was on site and that there were areas of intensity that we could then really focus our remedial efforts on. Oops, it wants to run again. Okay, we followed that up with correlation sampling. This correlation sampling, as I said, it was done on day 4 and 5 of the assessment. The project team was amazing in reviewing the data, making determinations on, well, what data is going to be, you know, beneficial for us. I'm not going to get into the specific numbers of everything. We certainly identified, you know, high levels that exceeded regulatory thresholds in individual constituents, as well as the gross petroleum ranges of gasoline and diesel and oil range organics. 2 weeks after we performed the HRSC assessment, we remobilized to the site to place monitoring wells, again, based on the results of the assessment. There were 4 monitoring wells that were placed within what we believe to be the extents of the NAPL body, and we did well clusters that were screened. They were screened in different vertical intervals based on the response that we saw. But then the majority of the wells that we placed were point of compliance wells, which are obviously necessary to, again, make that qualitative information that we have supported by empirical information. Approximately a month after we began the high resolution assessment, we moved into, sorry, I'm just lost my notes for a second. We moved into the groundwater sampling. And again, sort of as identified in the UVOST assessment, wells that were expected to contain NAPL did contain NAPL. Our point of compliance wells largely held up as point of compliance wells. There was widespread diesel impacts that were identified at lower levels, but frankly, there were more sources that we identified than we anticipated coming into this. So now let's kind of get into the post-production. So we gathered all that information in a month, and frankly, it was a lot of information, and we're still unpacking it. But here is a representation of the UVOST signal response in horizontal planes in the subsurface. So what you see to the left is, well, here's the overall footprint, but then as you go left to right and top to bottom, you see them in different vertical intervals. So really that 5 to 10 foot vertical interval is where a lot of the impact was observed. And you can get this understanding from soil sample collection. It's more difficult to kind of get this, a three-dimensional model developed with that approach. The cutoffs that were selected, the broad cutoff that was selected was a 5% RE response cutoff, and that is generally within the industry accepted as being representative of having NAPL in the pore space. It doesn't mean that NAPL is mobile and can go into a monitoring well. We found a pretty good correlation with the 100% RE signal and where our mobile NAPL resides. Looking next at vertical cross sections. So what this depicts is, this is looking north-south, and we're looking at that UVOST response contrasted against what the hydraulic profile tool told us, and that gives us a sense of soil permeability and associated hydraulic conductivity. And then we also contrasted it against the lithology that we basically had to piece together through our boring log interpretation. I think the three things that I kind of want to point out on this slide and the next are, one, the model is estimating near direct contact with the NAPL body to the basement in the building. So, this started out with a vapor concern being identified by employees. We identified subslab soil gas. Subsequent mobilizations that we had over the course of the late 2022 assessment identified direct, water and likely product intrusion into the building. So our model bore that out. The other things that it bore out were elevated UVOS response, generally correlated to areas of higher hydraulic conductivity and areas of coarser grained soils. Essentially, the product currently resides, it followed the path of least resistance. This shouldn't come as, a shocker to anyone, but again, getting all the information that you get in a single mobilization and being able to piece together this understanding really helps us determine what are we going to do next. And here we have the east-west interpretation. And really what the east-west interpretation shows is that there are a lot of different sources. Some of those sources appear to maybe be releases that are emanating from the building. I'm sure that there were surficial releases over the historic operations on the site. We haven't pieced all those things together quite yet. Continuing with LNAPL characteristics and sort of post HRSC assessment, we went into a 3 months phase of just going out and getting fluid level measurements from the well. As the 2021 comment letter from the state agency identified, hey, that 4.5 feet of product that you have, that's probably going to require hydraulic recovery or some form of recovery. What these diagnostic gauge plots allowed us to do is essentially identify some perched conditions in the formation, and perched conditions lead to exaggerated in-well thicknesses in the monitoring wells. So when we see 6 feet of product in the monitoring well, it's not 6 feet of product moving through the formation. It's more just representative of the fact that it is a perched lens. I think the last slide that I'm going to briefly review is going back to those pretty colors that we saw when we performed the assessment. And there are a lot of ways to try to go about to figure out, well, what exact product types do we have? One of the recommendations that we had was LNAPL fingerprinting. We haven't yet performed that, but what we wanted to do was annotate all of the downhole logs with associated analytical data. And what that was pretty informative to us. And again, this is still in progress. I do want to circle back with Dakota Technologies to provide them with our interpretation, partner with them on their interpretation. It's a continued part of the process, but understanding the product types does help inform us on what type of technologies are going to best serve these releases. So with that, I'm gonna turn it over to Hilary to start our summary.
So what do we know now? We started this whole process with the list of issues on the left, and we've taken this whole journey and collected all this data over the course of those first few weeks and the 4 months, you know, between when we started and when we stopped the fluid level monitoring. And in that brief amount of time, we have confirmed that we have multiple sources and fuel types, and we have a better correlation or understanding of what those fuel types are. And we've also confirmed that we have perched LNAPL conditions versus a massive plume that's migrating through the subsurface. Our better understanding and more detailed understanding of the conditions in the subsurface also allowed us to sort of redirect our approach to that indoor air quality issue and make alternative considerations to how we want to approach the remediation, including whether or not it's worth keeping the building or if removal of the entire building in a targeted excavation would be more appropriate based on the intentions of the client. And we've also defined what our contaminants of concern are.
So we're about to turn into performing our evaluation of what to do next. But to tease that a little bit, the areas and the volumetric extents of what we identified as really where the source resides, really we're looking at about a 13,000 square foot area for where that 5% RE response was. And that coincides with approximately a 3,300 cubic yard, or I'm sorry, a 2,400 cubic yard estimate for where the 5% area is. Now, if we wanted to focus on the 100% area, well, that's closer to 3,200 square feet and 250 cubic yards. Now, I should say that those numbers I gave are based on the model and the kriging methods employed. If we were to say perform an excavation, we can't do a three-dimensional printer, you know, and just go and do the excavation that way. But having an understanding of the sizes and quantities that we may be dealing with will further inform what remedial actions we determine to take for the site.
And so we've really ended up with 4 key takeaways from this whole process. And 3 of them directly relate to the goals of the 3 stakeholders involved that we defined at the beginning. We've determined the definition of the impacts at the site. We're fully defined. We understand what our sources are. We completed it on an accelerated schedule, which is beneficial to our client, and we have a well-documented understanding that we can then develop into our conceptual site model and provide appropriate remedial alternatives both to our client and to the regulatory agency. So with that, thank you for your time, and we'll field any questions if there are any.
Great. Yeah, very interesting. I don't see any questions in the Q&A, but I have a couple, if you will. Are there, other than the indoor air potential risk, are there other risk considerations that will go into the conceptual site model? And the secondary question is, what is the timetable for remediation as you move forward?
Well, other risk considerations We haven't performed. I'm just thinking of there's certainly it does appear that we need to evaluate the potential for interception to utilities as a completed exposure pathway. We need to evaluate, I mean, knowing where the contamination is, which is largely 5 to 13 feet below subsurface, I don't believe that there are potential impacts to groundwater drinking wells. So the rest of the exposure pathways are there's contaminant concentrations above standard. There's an ample amount of product in well, which in various states may or may not trigger action. And then there are impacts beyond the property boundary. But from a risk standpoint, absolutely the biggest concern is indoor air, which is why the building's vacant and why we're in discussions of what do we want to do with this building? It's not in great shapes right now, and it also has other issues associated with it.
Great, thank you for that. A couple questions did pop up. One is, how many soil or water samples required lab analysis, and were they analyzed on site or were they sent off to a lab for analysis, and did that impact your schedule at all?
We didn't do we didn't do an on-site lab. That was something that was considered. I think the correlation samples, we did 11 correlation soil borings, and there was maybe upwards of 30 samples collected. They were on an accelerated turnaround time, so it didn't impact the schedule that we developed. We received the soil analytical data back 3 days after we collected it, and a week and a half before we placed our monitoring wells. And so that soil analytical data did come into play with it. And then as far as the groundwater monitoring wells go, we installed an additional 8 wells, 4 of which were those clustered source wells, and the other 4 of which were point of compliance wells.
Okay, and then one final question, and you touched on this a little bit, but are you at the point yet where your remedial activities are planned? And if so, what kind of schedule do you think that those activities will have moving forward?
Right. Well, this, frankly, this presentation helped prompt us to get to this point, which is stating our known understandings of the site. Where we're at right now, Brian, as the question you asked is, let's perform the risk evaluation and let's really identify what are actionable things that we need to do. That will require re-engagement of all the stakeholders, the client as well as the regulatory body. We did not do the LNAPL transmissivity testing, which is something that we would definitely want to see happen if we were going to consider recovery. I think the weathering of the product types that we saw, the heavier nature of the product types we saw, leads me to believe that the transmissivity would likely be low. But of course, that's why we do the testing, to actually see what kind of hydraulic recovery could we have. But the fact that we have near land control of the body and that the extents are not deep, this isn't to 40 feet, this is to 15 feet. With the land control and the sizes that we're looking for, a lot of the fun things that we wanted to do related to, let's keep digging into these waveforms and these different product types. It may very well be, let's excavate a targeted area, consideration of land farming to minimize cost, minimize the footprint associated with that action. That is speculative. It's not agreed upon by anyone, but those are things that I think are on the table, where a lot of times they're not on the table because of other site logistics.
All right, well, thank you both for that. That was very interesting. Appreciate you being here today and sharing your insight and knowledge with us and answering a few questions. So thank you so much for being part of the afternoon.
Thank you.
Thank you.
All right, that brings us to our final speakers of the day, and that's Jared Abraham and Paul Ivancie. They will be providing us with an overview of Airborne Geophysical program to evaluate the Tertiary, Ogallala, and White River groups. Hydrostratigraphy in Laramie County, Wyoming. And I see they got their presentation up already. So I'll do the quick intros and we'll let you guys get to it. Jared is a principal geologist, geophysicist with Aqua Geoframeworks LLC, with offices in Fort Laramie, Wyoming, and Georgetown, Colorado. He's received his master's in science and geophysics from the Colorado School of Mines, and a bachelorette in science and geology from Mesa State College, and has concluded research internships with the University of Alaska Fairbanks Geophysical Institute. He holds professional geologist license in Arizona, Arkansas, Florida, Kansas, Nebraska, Utah, Texas, and Wyoming, and also holds a professional geophysicist license with the state of California. Joining Jared, I think, is Paul on the line, and Paul is a geologist with WPS USA Environmental and Infrastructure Incorporated in Laramie, Wyoming. Welcome, Jared and Paul, and please take it away.
Great. Can you guys hear me okay?
You bet.
Excellent. Paul, are you coming through okay?
Yeah, Jared, do you copy?
Yep. Great.
Here we are.
Well, hey, you guys. I really appreciate everyone, the invitation by the organizers, and our last presentation is a great little lead in. We're going to talk a little bit about some of the same things. It really boils down to what is our hydrogeologic framework that we're trying to get at. And Paul brought me into this project. He had worked on it for quite some time. So we're going to kind of tag team as we go through and kind of share with you where we ended up with a 12-mile long plume. So we've kind of blown the scale up of what we've been talking about today. So first, key personnel. We've had a lot of great people we worked with on this. Paul and I didn't do it ourselves. We're going to hit on the initial effort. Paul's going to lead that up. Where did the Airborne come in and why? And maybe that'll lead some of the audience to say, is this a practical technology and not? And then sort of the conceptual site model. Where did we end up in 2019 and where that has led the Corps and the city to go to from them. The key personnel, Doug Suppleman was a project manager, had a lot of trust in us out of the Omaha district. Aqua Geoframeworks, myself, Jim Cania, Ted Ash, and then WSP, and they've been through a few different names. And Paul, of course, Jim Field, David Miller, Evan Thomas, Jerry Eichholt, and Paige Stork were all super critical in putting this all together. So with that, Paul, why don't you tell us a bit of how we got to where we are today?
Yeah, a little background on the project. This site that we're discussing today is a former Atlas D missile site 4 that was active in the 60s during the Cold War. In the lower inset map, you can see that the location of our project is west of Cheyenne, just south of I-80. There's an inset where the former Atlas site was, 3 missile gantries that were active during the 60s, and during their activities, much of the practicing of launches and things like that had readiness exercises, where many of those exercises released about 16,000 gallons allegedly of TCE released over those 3 years of operation directly into the flame pitch and the launch facilities. Ultimately, that trichloroethane was the contaminant concern. It migrated vertically through the unsaturated Ogallala formation and literally migrated laterally around 12 to 13 miles east of the source area, the launch service buildings there. Next slide, Jared. This is a view of that contaminant pathway, or the plume, as we walked into it in 2017, or excuse me, 2015. Much of our exercise, the initial contract with the Corps of Engineers Omaha, was to help assemble the volumes of data out here. There's a series of municipal wells and industrial wells that are affected by this plume, and domestic wells, many of which were on the eastern end of the site. The areas that we were concerned with was the source area, area A, transition area, which was slope down gradient. Gradient is a strong gradient from west to east. And then the larger expanded area, which area B, which was really our determination of where is the breadth of this plume. And at this time, we did not know the end of the plume. So again, a pretty big, vast area. If you look from west to east, we're looking at over 14 miles. Jared, anything else on that map that's
Nope, I think you got it. Great.
let's look at some geology of the site. We are on the inset map of the High Plains Aquifer. As you can see in Wyoming, we're in the westernmost extent of the Ogallala and High Plains Aquifer system. Here to the left is a block diagram showing what's called the gangplank. There's I-80, which makes its way to Laramie from Cheyenne. The Union Pacific Railroad actually used this ramp to get over the mountains into Laramie and continue their way onto the Pacific. But if you look at that in cross section more idealized in the lower portion, you can see that ramp of tertiary undifferentiated material overlying the Cretaceous deeper units, a very complex area. But we're concerned today with that tertiary system where the contaminant pathway had migrated through. That's from Blackstone at the University of Wyoming. Jared, do you want to, this is a very great diagram, kind of looking at the discrete hydrogeology and geologic units of what we're concerned with today.
Yeah, this is a recent publication out of the University of Nebraska, based on quite a bit of airborne work and kind of thinking about the High Plains and the High Plains Aquifer systems, Ogallala group, Mercury group, and the White River group, and how those paleochannel systems evolved and how their basically layout and the metamorphosis of those deposits over time. So the real important thing is the Ogallala is full of these anastomosing stream systems and imbricated streams where most of the coarse aquifer exists. As we move into the Mercury group, which doesn't exist in much of the study area, but is a High Plains contributor, and sitting on top of the White River, the Ogallala is really the big player in this area. And a lot of the investigations that we're a part of and the follow-up drilling has indicated that.
Well, part of the effort here, to give you more background, the data synthesis report, we were responsible for addressing 8 problem statements at that stage in 2014, 2015. The stakeholders wanted to know more about the geology, the hydrogeology, fate transport, chemistry, geochemistry, the potential exposure pathways, and really the overall understanding of the hydrogeology out here. Through my experience, having worked with the city of Cheyenne and DANR and the industrial folks in their well fields, we had put together a database of over 200 technical reports, over 5,000 geophysical logs, lithologic logs, many databases, and we were assembling a conceptual site model where we could understand the environmental site stratigraphy more in depth. We had a searchable database that put together water levels, cross sections, everything you wanted to know historically about the site. Was quite an involved process of about 2 years. We submitted that in a form of a technical memorandum in 2015. Some of the conceptual site model that resulted from that effort, if you can see that cross section, what we're dealing with here is a alluvial fan system, which is very broad off the mountain front, showing the proximal, medial and distal portions of the fan in that cross section, but poorly understood between the wells we had. The same for the 3D block diagram that we established in Earth Volume Studio, which is a 3D program where our stratigraphy was somewhat known, but the everything between the wells was poorly misunderstood. we're trying to get a better understanding of it. Next slide. So following that effort, and in the inset map there below, you can see a number of the cross sections and all the data that we had put together over that 14-mile site, including that area near I-25 in the east and then south of the I-80 there. At that stage, there were installation of monitoring wells. We had a basic understanding of where the plume may go, but we did not know the terminus of the plume. At that stage, I was introduced to Aqua Frameworks through some very good acquaintances of the geophysical community, and Jared and I had put together a program to try and survey this with the goal of understanding the hydrogeologic framework with better information between wells and a better understanding of where we might find the end of this plume. Jared, you want to take it into the next slide?
Yeah, so what Paul had kind of seen is quite a few years of work from 2007 to we're flying surveys this year. The state of Nebraska has had a very active airborne mapping program. Much of it started out in the eastern section of the glaciated part, but has continued on. And with we have quite a bit of experience in mapping Ogallala aquifer materials. In fact, right up against the border in Pine Bluffs. So Paul had seen some of this work. A lot of it's publicly available, and said, and called me up and basically said, Jared, is this something that would work? And I said, Ogallala, White River Group, I think we can do this. So what we've got is a little bit of a tutorial on what are we doing here. So hopefully my little cartoon's running for everyone. The way airborne electromagnetics works, and it was developed right after World War II out of the submarine detection program. And as they flew these sensors over the Earth, they started seeing where there's quite a bit of changes in the geology from some of the initial work that was done by the Schlumberger brothers and others using modern airborne platforms. Can we do a substantial amount of mapping? And when you think of areas like northern Canada and Alaska, where it's absolutely flat, muskeg, it's hard to access, aircraft change the ability to map. And if there are detectable differences in the subsurface, airborne EM can be a real beneficial to locating, going in and drilling. Airborne's not, replacing good hydrology and good geology. It's helping target that in areas that are difficult. The way this works is the system flies about 100 feet off the surface of the Earth, 100 feet below the helicopter, and we pulse the Earth. And these are in microseconds here. And the real key to this is as the EM waves diffuse in the Earth, that rate of diffusion where we're generating secondary currents that we're also recording is reflected. And so we have a little apparent resistivity curve over here. And as we move from 100 ohm resistivity to 10 ohm resistivity, there's a time shift that we can see that's changing how that decay goes in time. And that's what we're really trying to get at, is looking at some of those changes and how they exist vertically and horizontally. This system we're looking at can see about 1,000 feet readily. Bigger systems can see down to about a maximum of 2,500 feet. Now, we are sensing the resistivity of the rocks. And I put this slide up here to really bring home, you can't decouple yourself from geology and hydrology ever. So you look at this, you say, wow, 7 orders of magnitude. This is amazing. We can really tell the difference. Well, the sad truth is, let me get my little slide up here. If someone says, so Jared, it's 100 ohm resistivity, 100 ohm meter resistivity, what is it? Well, it's felsic or metamorphic or tills and clays or sandstone, lignite, sea ice, or maybe it's fresh water. The point is just having that resistivity is not going to tell us the whole story of what's going on. We have to look at the geology and the boreholes and the water quality to decouple what these resistivity signals really mean. So how was this done? Well, we fly a helicopter back and forth across the earth, thinking about mowing the lawn, and out comes these absolutely useless things for geologists and hydrologists: in phase and quadrature, amplitude versus time. Absolutely useless. What we have to do is to convert this through a numerical inversion into some interval conductivity or resistivity over depth. You're doing thousands of these going back and forth to the earth. Now we can start looking at the distribution of resistivity in 3 space or a 3D model, a 3D cube. Now this can be useful for looking at hydrology. So this is a really important step, is going from these raw signals to something useful. And that's kind of where we're going to go from here on. So the Atlas Site 4 Airborne Geophysical Program, the whole objective is increase the understanding of the aquifers for the Ogallala and the White River, the hydrostratigraphy within the eastern expanded area, this headless snake, as Paul's described it before. Where is the contamination going? As you can imagine, concerned citizens in Cheyenne, property owners to the east, the government's trying to poison us. I mean, you can imagine these public meetings, not a lot of happiness. We need to integrate all these existing data that Paul told you about in the initial data discovery phase and define the down gradient edge of the groundwater plume. Recommend drilling location. So instead of going out and drilling hundreds of holes, can we do dozens of holes to really put the in to the contaminant plume? And then refine that, update that conceptual site model. And it's a constant feedback as more wells are sampled, a better understanding of what's going on. And so that was the main goals of the study. Well, when we started down here, how do we know airborne geophysics programs even going to work? Well, I'm telling you today, as someone who's done this most of their career, do not ever do one of these geophysical surveys without doing some what we call forward modeling or assessments on the ability of the technology to detect what's important. Now, does physics work? Yes, terribly well, as anyone that stepped out of a three-story building has learned. But the point is can we detect these differences at the heights we're seeing? Where do you start is a ground model, geologic model, or truth. And everyone knows Theseus ended up in the deepest level of hell by virgin. So truth is a big word, but we need to start with something that gives us some trust in what we're seeing. Borehole geophysical logs, lithology logs. From that, we come up with a simplified model. What would the theoretical airborne response be? Okay, this is this amplitude with time, again, geologically meaningless. Turn that into some geophysical signal or a geophysical virtual borehole. And is that going to actually be able to show us what we're looking at? From that, derive our system parameters. There are many different systems out there that are optimized for shallow and deep and resistive targets and conductive targets. And the whole idea is we want to turn that system. And anyone that's ever worked with a pH meter or a specific conductance meter, all EM systems drift always. You have to deal with that, and you have to have a plan to deal with that. So that's a critical part before you even bring a helicopter to the site. So the next part is flight planning. So this is the city of Cheyenne up here. We have I-80. As Paul talked about, this is the source area. This is where the launch site is. This is approximately 12 miles downhill. We had priorities, weather, fuel limitations, breakages. Helicopters do break. So we wanted to do this in stages. Priority 1 on this eastern end, priority 2, filling in a lot in here, and then a priority 3. And we actually were blessed with really great weather right after a pretty decent snowstorm in May over Memorial Day weekend in 2017. And we're actually able to collect even more than what we had planned to do. So the acquisition went from May 27th through the 1st, mobilized to the area. Survey was flown May 29th to June 1st. We covered approximately 386.7 line miles or 622.4 line kilometers. Required over the area between May 30th and June 1st. So we moved into this area. Due to favorable weather, we did very well. The inversion manually processing of the survey data was applied for possible electromagnetic couplings. After final processing, we ended up with 403.8 line kilometers of data. Data retention of about 65% due to the high number of power lines, pipelines, and other infrastructure. So we were really happy with that. So I hope everyone's saying, well, that's great, Jared. What is this going to actually look like? So boom, let's take a look at this. Now, again, we're looking at a scale of about 12 miles across here. So what we have plotted here is a view to the northwest, a vertical exaggeration of about 5. And this is our resistivity scale here. So in this scale, our hot colors or high resistivity areas are those things that our previous presenters talked about, the coarse zones, coarse portions of the Ogallala. And what we can see as we move from the west to the east downhill, we see pinks and reds and yellows and oranges. And then all of a sudden things are starting to come to an end down here. So we're going to explore that in some more detail. So let's look at a cross section. So this is one of our first preliminary cross sections that we put together here. I have a well that's representing borehole resistivity that I've projected into the flight line. It's within about 1,500 feet of the flight line. So we're going from the source area here in the west downhill all the way to the east. And the one thing that's apparent we see is a very resistive, this pink color we've had it represented, moving down here, and this bright blue or very conductive areas down in here, moving to a more green color. And this is going to be really critical as we talk about what is this actually shown us. Now, Paul also talked about historical data. In the area we've collected, or the Corps has collected both ground-based EM and seismic in the source area. Those data are not bad. Utilize everything you have. And this is overlaying some of the airborne geophysics. We have boreholes projected here in this cross section and the seismic in the back, looking at where some of these contacts exist. So again, we use everything. Here is some historical time domain EM soundings placed on the seismic here. We have our contacts, Tertiary Ogallala and the White River group here, and several boreholes. Again, these are projected in about 1,500 feet. So there are variations are due to be offset from the lines. Again, because we have all this represented in three-dimensional space, we can bring this all together. We have airborne lines, we have boreholes, we have borehole geophysics, we have ground-based EM, and we have seismic, all representing what's happening out into the source area. So the next step is to move it away from this resistivity to something that's actually is more related to our hydrology. So what we did is we came up with a resistivity to lithology transform. And we're showing you guys a portion of the line. So here's kind of an inset map. So this is starting in the source area and moving downhill to the east. And it's just short of the expanded area. But what we see here is some important changes. Again, we see these color changes through here. We have our borehole control. The orange is Ogallala. The reddish color is White River Group. And then we've actually converted the resistivities to a lithologic model. So we have gravels of the Ogallala in here, moving to sands, some silt layers down into the White River Group. Down here, this is mostly Lance. On the very eastern end, there's some other units that exist. But the other thing that's important, as we move through here, we start seeing more and more of the clay minerals occurring. Paul, anything to add to this kind of general down the hill slide?
Yeah, one of the really interesting points there is if you see the water level, this is the westernmost portion of the water table in the regional area there on the ranch. The ranch there is a 17,000 acre parcel, but this was very much matched up with the data we had. We could see where the edge of the aquifer was, and that was the westernmost part of the Ogallala in this part of southeast Wyoming.
So
Also, the
now,
contrast is pretty amazing between the Ogallala and the White River on that right side of the panel.
so now we're going to move to the same line, but move downhill to the expanded study area. So we've done an inset here. And now we're going to start explaining what we learned about this alluvial fan. So this is the portion of the line we're looking at. These are sections up here. So, you know, we're going to get 1, 2, 3, 4, approximately 5 miles long line. This is where it is on the map. Again, I-80s, or excuse me, I-25 is right here. I-80 is right here. City of Cheyenne would be off. It's right here. Looking at this current profile, this is our borehole control and the resistivity. And notice as we move down, we have our water table plotted on here as this dashed blue line. We're moving down, we see these red colors, green colors, and then abruptly changing into these blue and cyan colors. Transforming that to our lithologic model down below, what we're seeing is as we moved in here, we go from gravels and sands moving to an interbedded situation to more clay dominated end. And this is the distal end of the fan. And I think in the next images, we'll be able to show that to you. Paul, anything to add here?
No, but most, yes, the wells on this end of the fan were artesian and confined.
Another clue. So this is a line right through kind of the western end of this expanded area. So we're kind of looking at what's the fabric of the fan at this level. So here again, 1, 2, 3, 4 mile long section. Up here, we have our borehole control showing our stratigraphy. We have the water table as interpolated in the area. On the resistivity, again, we see this bright contrast in the resistivities right at the contact of the White River group. Moving down to our lithologic model, we see where we have our clays and our sands and gravels and matching up well with our borehole control in the area. As many of you know, not all boreholes are created equal, but they all have use. And that's an important thing. So now I want to show you taking this out, looking at this into the fan structure, where we're trying to get at what's happening in the subsurface and where this contaminant plume may be ending. So what we've displayed here for you all is the gravel, the sand, and the interbedded units that are saturated on the eastern end of the survey. And what you notice is in this gray area, that doesn't mean we don't have data there. It means that these are clay materials. So what's happening at the distal end of this system, we are running out of good aquifer material. Paul, anything else to add?
The red squares were proposed wells by the Army Corps. They had twice as many planned. We had reduced that number in half or less. The blue dots represent the DANR well field and some of the Cheyenne's Bory well field too.
Excellent. Here's a little different view, more of a isopac thickness map of what that saturated Ogallala aquifer materials look at. And you notice it's thicker here to the west and becomes quite thin and absent here in the east, the gray shaded area. So at this point, we integrated it into the conceptual site model. So Paul, you want to talk a little bit about how your team did that?
Yeah, we took our earlier stratigraphic model, the Earth Volumetric Studio, and we were able to integrate it with the products from the AEM and combine the two with the power of our many geophysical logs we had in the area, normalized resistivities and lithologies, and we were able to park that in with and correlate to Jared's model, which was very unique and it worked great. We did get a water level surface from many of the wells we had in the area. So we would really data rich area, but having to normalize it all was the challenge. But I think through the using our Earth Volume Studio 3D program with Jared's work, we were able to integrate everything. And Jared, here's a view of if you want to go through this.
Yeah, this is in the EVS system that was used for, and again, same color distributions that we put together. And again, showing a bit in 3D this distal end of the fan. And what we've done here is we've actually put that headless snake to the plume out here. And so what we did with the core is we proposed that this would be the end of their contamination based on the hydrogeologic parameters of the aquifer materials in here. So that's what needed to be drilled out. So I don't know if there's any geophysical doubters in the audience, but I'm one of them, the speaker. So one of the big things is the Corps said, well, that's great, Jared and Paul. You've spent a lot of money and you've put some nice graphics together. We want to prove this out. So of course, they picked a drill hole location. This is Monitor 95, the X, as far away from our data points as you could get along a line. But still, let's take a look at it and see how well did the geophysics do it at looking at our materials. So this is a busy slide, so I'll walk through what I'm showing. I've got the induction long and induction short log. So the long is the blue, the short is the black, and that's the high frequency plots we see here. I have the airborne EM sounding that's 670 feet to the north, and the airborne EM sounding that's 680 feet to the south of the drill hole. I have the borehole lithology over here on the right with the standardized lithologic terms that were used. And I have where we picked the tertiary White River contact through here. And these X's are related to where we felt they were based on the sounding to the north, the sounding to the south, and doing a simple interpolation here. And right here where they had no sample, this is right where the tertiary White River contact was. So after this, the Corps had a lot of trust in what we did, and they continued their drilling program from there. And the next slide kind of shows in 2020 where the Corps had determined the end of the plume was and how that corresponds to the previous plume boundary or the unknown extent that existed. So this presented this in a couple different public forums, and it was really interesting how the conversation moved from a pointing fingers game to, well, now this is what we have. How do we go about solving it? And the Corps goes about remedial action plans with the city's buy-in, the state's buy-in, and the community group buy-in. So Paul, anything else to kind of add on this slide?
Well, we did come within feet of our objectives. We warned for example, we warned them about drilling monitor well 97 on the eastern confined area and the well flowed artesian and somewhat out of control on them. But it just proof was in. It was validated that I think we came very close to the model, and we still do. The good news here is that we're able to get a win-win situation with the Corps and the Cheyenne Board of Public Utilities and others in the area, where we're now taking this data and working towards characterizing the municipal water supply in the area, the entire area. So it's been really a win-win for them, and we continue that work today. but I think here's a kind of when we finished this work, we were asked to go and complete the remainder of the area, and we put the entire conceptual site model together for the Corps, defining that framework along the 13-mile long path. What we did deliver was a very pinpoint direction and which channel the contaminant was residing in, reducing their 25 to 30 well program to just less than 5-7 wells. So we did save them, I think, an enormous amount of money. But we provided them with some great products. And again, on the last statement there, Jared has been instrumental in making us look very good as we continue our work to help the board in their study of their well fields from north to south. We've continued flying the area in excess of how many additional miles, Jared? There's the new flights that we've just completed in the fall.
Doubled, we've doubled the coverage.
And we're now looking at managed aquifer storage programs and looking at the extent and breadth of their municipal water supply, parlaying everything we learned on the contaminant for the Corps. So it's a good situation, and we continue to I think answer a lot of questions for the folks out there.
And it's really the takeaway. And I know the Corps was awarded some internal recognition for using technology and reducing their drilling costs, which really is what it boiled down to. And they moved on to their remedial action plan, et cetera. And I think actually they're working on some of the remediation currently. What was even a bigger benefit is we're able to broker data sharing with the state and the city, and the city has come in and flown additional data up in here in their well fields. So this taxpayer funded airborne project has actually benefited the people of Cheyenne in looking at their well fields. So a bit of a win-win, as Paul said. So
I might mention that the Jared was instrumental in helping the city of town of Laramie in a similar program west of the divide there with the University of Wyoming. And we continue to try and help Southeast Wyoming using this technology. And that's about it, Jared.
Well, at that, I want to thank the organizers and everyone that's still along with us. We really greatly appreciate the opportunity to share our passion for mapping geology, and we hope this leaves you guys with some ideas on if you're confronted with a 12-mile long plume. There are some technologies that may be able to help, and they're grounded in traditional understanding of the hydrogeology and hydrogeologic framework. So again, thank you very much.
Thank you.
Thank both of you, Jared and Paul, for that. It was great. I'll ask one quick question before we shut down for the day. Is there, talk about a 12-mile plume, is there a minimal scale limitation to whether this technology is useful? If that's a reasonable question.
Sure, I think it is. I tell people to think on scales of townships, right? Not sections. And it's not that the airborne EM technology doesn't work. Of course it works. And we sample, 10 times a second. We're getting a sample every 30 meters or 100 feet. So, but it's mobilizing into an area. Helicopters, crews, it's like drilling a well. It's a lot of mobilization to make things happen. So you really need to think more in the scale of townships, that's where this technology can really make it, or areas where you don't have ground access. Sure. I mean, one of the issues that the Corps was confronted with is extremely hostile land ownership in this area where they couldn't get drill rigs into to sample. So by being able to give them this roadmap of where these coarse materials were or how we interpreted them, they could go in and start targeting and deal with those land access issues on a 1-by-1 hole basis instead of shotgun approach where, we're looking at, 8 years to do, just the investigation part of the study. So that really helped. So think about township scale or areas where it's extremely difficult to do the work. I've done some work in mining areas in Colorado where we're only looking at about 100 line kilometers, but because of the terrain and the land ownership, ground-based geophysics and sampling just didn't make sense.
Interesting. All right. Well, seeing no more questions, thank you again very much. And thank you to all our speakers today. I think we had some excellent topics, and I know I learned a few things, and I hope everyone else did too. Appreciate everyone's time that they've given to us today to both present and to participate. A quick reminder, if you're looking for those contact hours, please email Brian Ferris on my team. That's brian.faris@state.sde.us, and he will help you out. With that, I hope everybody has a great evening tonight. Spring's coming, which is good, although we're supposed to get some snow on Friday here in Pierce, so we'll see how that goes. Everybody take care, and we'll see you later.
Goodbye.
Goodbye.